forced normal cells to, in a way, become cancerous. We call that a disease, but if we really look at it, it's almost a survival mechanism of the cell, switching from one way of going about creating energy to being forced to consuming energy through another pathway, this fermentation pathway. But in that process, the cells, the cancer cells, which were previously healthy, they now have become out of control and they have dysregulated, unregulated growth, which ultimately ends up leading to a whole cascading situations of problems. Is that accurate? Is there anything I missed in that?
No, I think that's pretty good. I think you did a good job on that. And I think that and during this process of mitochondrial dysfunction that happens gradually, the mitochondria throw out what we call reactive oxygen species, ROS. These are radical species that can damage proteins, lipids, and the DNA, the nucleic acids, RNA and DNA, can be damaged by these ROS. So they are largely they come out of the mitochondria because the mitochondria, as the mitochondria of the cell becomes more and more dysfunctional, they produce, rather than producing ATP, the energy that they normally would produce, they produce ROS. And the ROS are carcinogenic and mutagenic. So the mutations that you see in the cancer cell are downstream effects of the damage to the reactive of the mitochondria. So the field of cancer is focusing their energies and their attention on downstream stuff that is not relevant to the majority of cancers. So when you hear people speak of the ALK mutation, the P53 mutation, and all these mutations, they're all downstream effects. They're not the cause of cancer. They're the effects of the production of reactive oxygen species because the mitochondria have become abnormal. They're throwing out these radicals that are damaging lipids and proteins and causing mutations in the nucleus. And the field, almost the entire cancer field, is focused on all this kind of stuff. And I'm saying, and others in Warburg said, no, you got to go back and figure out where the energy is coming from, because you're collecting mutations in the nucleus that are largely irrelevant, but they're coming because of the acidification in the microenvironment. They're coming because of the reactive oxygen species. But the most important question is, what is the fuel that is driving the dysregulated cell growth? Okay, what's the energy? What are these cells using to divide? And as you said, when we go back in time, we find out that all of the cells that existed on the planet were using those ancient fermentation pathways because there was no oxygen in the atmosphere. So they grew dysregulated growth. And the interesting thing is they would grow without regulation until the fermentable fuels in the microenvironment were dissipated. And then these cells would up and die. So that told me right away that the way you kill cancer cells is you deprive them of their fermentable fuels. And because that's what's driving the dysregulated growth. They're dysregulated because the mitochondria are no longer in control of the system. And now they're just growing as long as they have fermentable fuels, just like our ancestral cells 2.5 billion years ago. So now, why did biology start to have integrated action? And that was with the symbiotic interaction between one type of protista bacteria that could harvest the energy of oxygen in the cell, which led to metazoans, which are more than one cell. They're multicellular. Multicellularity arose with the origin of the mitochondria in the cytoplasm. That led to regulated growth. So you have to go back really long in evolutionary terms to find such systems where preceded mitochondria in the evolution of organisms on the planet. And these cancer cells are going back that far. So they will grow out of control as long as they have fermentation fuels in their microenvironment. And as we have shown, and Warburg had shown, glucose is a prime fermentable fuel in the microenvironment of the tumor cell. And as we have now shown, the amino acid glutamine is another fermentable fuel in the tumor microenvironment. So the solution to the cancer problem now becomes very clear. You need to restrict the availability of the fermentable fuels while transitioning the body over to fuels that cannot be fermented, like fatty acids and ketone bodies. So this is a clear strategy to manage cancer without toxicity. You target simultaneously the two fuels that are driving the beast, both fermentable fuels, and you transition the rest of the body over to glucose and glutamine are the fermentable fuels in the microenvironment, and then you transition the body over to ketone bodies or fatty acids, which cannot be fermented. So these two fuels cannot be fermented by cancer cells, which require fermentation for growth. So it becomes very clear. But ketones do not kill cancer cells. Ketones and fatty acids are for the good of the normal cells of our body. They don't need glucose and glutamine if they can respire fatty acids in ketone bodies. They don't have dysfunctional mitochondria. The cancer cell does. So we can marginalize the cancer cell simply by depriving it of its fermentable fuels and protecting all of the normal cells in the body by shifting them over to ketone bodies, which now becomes a non-fuel for the cancer cell.
So does that make sense? It absolutely makes sense. And really connecting the dots here for the audience that's following along, your early work in the field of epilepsy and showing that essentially a ketogenic diet, right? Because again, we're talking about that. And, ketogenic diet is the most studied diet when it comes to brain health and specifically people dealing with epilepsy. It was the first treatment, right, that was used for targeting, I believe it was kids originally. I think some tests.
Yeah, it was Wilder, 1921.
1921.
But he Wilder studied epilepsy, but he realized that if you put kids on water-only fasting, the seizures would go away.
Right.
But he realized that when you don't eat food, what's the major changes in the blood? And the blood sugar goes down, and ketone bodies, which are water-soluble breakdown product of fats. So the fats in our body are mobilized. These fatty acids then go into the bloodstream. They go to the liver, and the liver chops them up like a wood chipper and makes small molecules called ketone bodies. And these are water-soluble products of the breakdown of fatty acids. And they go to the brain. They can replace glucose in the brain. They can be burned by the heart, by muscles. So the combination between ketone bodies and fatty acids can be respired if you have a good respiration system. With respect to epilepsy, now here's the interesting thing. So Wilder says, we can't cure epilepsy by starving people to death. So let's build a diet that does what a normal water-only fasting would do. And if you eat diets that have very low carbohydrates in restricted amounts, blood sugar goes down and ketones go up. So it was kind of a calorie-restricted fat diet. You can eat avocados and you could eat certain things that would give you fats. And that seemed to manage epileptic seizures. And then, of course, in the 1930s, certain drugs came on that made it a lot easier for patients. Say, we have a drug now that can do what a ketogenic diet does. So let's forget about the ketogenic diets. But Jim Abrams and his son Charlie started the Charlie Foundation because his son Charlie Abrams was almost killed by various drugs and treatments that he was taking when he could have done a ketogenic diet. So it was resurrected at the late 90s by Jim Abrams. And we were all working on epilepsy. And we found no uncertain terms that that management of seizures was directly linked to the blood glucose. And the difference between cancer and epilepsy is we really don't know how ketogenic diets stop epileptic seizures. We know it changes the energy metabolism of the brain, but the mechanisms, the clear mechanism is still under massive investigation. And it seems to work against a variety of different epilepsies. So some people inherit an epilepsy. Some people get it from a viral infection. Some people get it from a bang on the head. Some people get it from tumors. It seems like a ketogenic diet seems to reduce the excitability of the brain in many different interesting mechanisms, which are under investigation. But we do know that sometimes these children that have managed seizures for quite a long time, months, many months, all of a sudden take one sip of a Coca-Cola or a fruit juice or something, spiking the blood sugar, leading to an explosive breakthrough seizure, which is very clear. So my colleagues and I in the epilepsy field knew this, that how is it possible that you could have a child managed with seizures for such a long period of time, and all they have to do is take one sip of a fruit juice or a bite of a cupcake, and within minutes they're blown up into a major seizure. So it was clear that you had to maintain low stable blood sugar to manage an epileptic seizure. In cancer, we don't see an explosive growth of cells as the result of taking a bite out of a cupcake or a sugary drink. You can't see it, you can't feel it, but you know it's happening because we know the cancer cell can't live. One of the fermentable fuels is glucose. And sugar is fructose glucose, so it's broken down. So the glucose immediately goes to the tumor cell and is used for the growth of the tumor cell. But you can't say, well, the guy says, I've been ketogenic diet, I think I'm okay, let me just bite this cupcake. You can't see whether your tumor cell is going to be growing like you can see a breakthrough epileptic seizure. It's very clear, but not a growing tumor cell. You just have to know that to manage cancer, you have to keep that sugar under control. And the second fuel is glutamine, which there's no diet. And everybody keeps asking me, glutamine is so healthy for us and all this. And it is. People need to know that glutamine is not a risk factor for cancer. Glucose is for creating inflammation, but not glutamine. So you need specific drugs to target the glutamine for cancer. You can't do it with any diet. People, I take glutamine for weightlifting and all this other stuff. That's great. If you don't have cancer, don't worry about it. So glutamine is an important metabolite.
So to connect the dots, just like I did earlier with cancer and really talking about in a way to look at cancer as a survival mechanism as a cell, we see it as this destructive disease, which it absolutely is, and it causes havoc for people. But from a biological level, this is just a cell trying to survive. So it's tapping into an old evolutionary pathway, which is this fermentation process. So to bring that same sort of thinking over to these two fuel sources for cancer, specifically glucose, really what you're saying, if I understand correctly, please correct me if I'm wrong, is that a ketogenic diet as a therapeutic approach to cancer, in a way, is cutting off the fuel source that is used in this fermentation process. So still providing fuel for our healthy cells, but taking away the primary fuel sources that cancer uses to grow and grow rapidly inside of the body. Is that a correct understanding?
Yes. And the second part you said is absolutely essential. They have to know that the ketone bodies from the ketogenic diets are serving as fuel sources for the normal non-cancerous cells in our body, actually making them even healthier than they were. There's another interesting biochemical mechanism by which burning ketones enhances the health and vitality and energy efficiency of normal cells. So that's one issue. That is, the normal cells burning ketone bodies get healthier when on. That's why one of the health benefits of ketogenic diet. I hate to say ketogenic diet because it is that, but it's more than that. It's a general health. It's a health system for the body,
right? Because there's stress response is a major part of it, as you've talked about. There's many other things. It's not just that we're going to throw this one diet, although diet is a key part of removing the fuel source of cancer in your work and approach. But this is a whole system, and maybe when we have a few minutes here in a little bit, we can talk about what the whole system is.
Yeah, well, I think you're right. I mean, you have to break it down into its various parts.
Right.
So, ketosis in a diet can be achieved with carnivore diets, Mediterranean diets, even vegan diets, although not as effective, but they can still generate a state of ketosis, which is then putting pressure, making the normal cells healthy while at the same time restricting the fuel that's absolutely required for the growth of the tumor. So again, you have to bring the body into a more metabolically stabilized state. Once the body is into that state, then you can then use low doses of various kinds of drugs and procedures that will work synergistically with this new ketotic state, making these tumor cells more and more vulnerable to death by putting them under metabolic stress. And that stress is enhancing the healthy cells of the body while slowly degrading and eliminating the tumor cells.
Right. It's not that you're out there, somebody saying that, oh, just by cutting off the fuel source, these cells are going to die. No, there might need to be approaches like drugs, and there's a lot of great ones that are out there, and we're lucky through modern medicine to have access to them. But there could be a protocol to introduce low amounts that then can actually kill the cancer, depending on what type of cancer people are dealing with.
Yeah, and some of these drugs, can be used in very low concentrations, because the tumor cells now, when they're under this metabolic stress, become extremely vulnerable to killing. So we're not saying we can throw out all these chemotherapies and all this other kinds of stuff. We just need to know how to use it more effectively and in the right way, so that a patient can just take a small dose of this stuff when the body is in ketosis and then eliminate the tumor without toxicity. We know this. So that's why some of my colleagues in the clinic in Istanbul are using very low chemo drugs together with ketogenic metabolic therapy. It's a process by which we're both enhancing the health and vitality of the normal cells while slowly degrading tumor cells without producing significant toxicity in the rest of the body. It's a beautiful strategy. You just got to know about it. You have to understand what you're doing, why you're doing it, and you have to understand the nature of the biological processes, which makes this metabolic approach the most logical and likely will be the most effective way to manage cancer for the majority of tumors.
So we'll get into the challenge with the way that clinical trials are done today, because the question always from the people that are in the medical field are always like, well, where's the evidence? Where's the evidence? And usually they're talking about these randomized, placebo-controlled trials. We're going to get to that in a second. But first, let's talk about at least your studies of what you've shown in mice. And then also, I do believe that you've collected case studies that are out there. Do you have case studies in, I've seen the ones that are there in animals. Do you also have case studies in humans showing that when you starve the cancer and then also use these low dose concentrations of drugs to kill the cancer, that people can ultimately radically slow down or even, kill off the cancer that they're dealing with?
Yeah. I mean, this is the strategy, to slow the whole tumor down and degrade it very slowly. So
and have you and your team collected case studies together of different groups that are out there? It's still emerging, and obviously that's one of the big problems with this is that it's not like MD Anderson or the here in UCLA in Los Angeles is practicing this new approach. This is sort of a whole new approach to cancer in itself. But what documentation do we have, at least right now, before we get into clinical trials?
Okay, we base it on two things. Before you have to have a logical mechanism of action for doing something. In other words, there has to be a scientific basis for why you would do a trial in the first place. Okay, why you would treat a human, a mouse, a dog, or whatever. There has to be what do you just grab something off the shelf and chug it down? Maybe that solution over there might work. No, there's no mechanism. We in Warburg and others have clearly defined what the underlying process of the tumor cell is. Right? We know that from the preclinical studies, from the cell culture studies. We know that. We know we know what's driving the cell. So now take a human being that has a tumor, and you say, we're going to now, based on our understanding of the scientific mechanisms that are responsible for your dysregulated cell growth, we will now institute a therapeutic approach designed to target that process. And when we do that, we get really good results. The problem is you cannot take 50 people and do this, because you need to know each person you have to know that person's metabolism. You have to know that person's sex, age. You have to know what other conditions in that individual are there that need to be addressed before you can start doing this stuff. Before you can start treating a patient with ketogenic metabolic therapy, does that person have parasites? Does that person have type 2 diabetes, hypertension? There's a whole variety of things that have to be evaluated up front before you can then elicit a therapeutic strategy for managing that person's situation. So you need to do a very comprehensive blood work on that individual. And so you can take 20 individuals, and all 20 may have a different profile of blood markers and things. So you might have to ease one person in a little bit differently than another person. You need to try to manage as best you can, bring that person into a new metabolic state. Then once that person is in a metabolic state, then you can look at non-invasive strategies for managing his tumor. What is that? CAT scan, PET scan. These kinds of non-invasive ways to determine whether or not the individual's tumor is showing some level of response to the treatment that you're using. Then once you have that, the tumor becomes somewhat stabilized. Then you can then introduce very low doses of certain drugs that are known to act synergistically with the diet or with the new metabolic homeostatic state. Drugs that will target the glycolysis, the glucose utilizing pathway. Drugs that target the glutamine utilizing pathway. And they would be delivered in pulses, and they would not be delivered in great excess amounts because they're working synergistically. How do you ask the guy, how are you feeling today? I feel great. What are you guys doing? So I said, well, that's good. That's a good first step. So we can't, people, where's the evidence? What are you going to do? Take 100 people and just, throw something at them that you have no clue. You don't understand the biology. You don't understand. You gotta, we work with small numbers of people, individual case reports, and then we publish those case reports. And then we look at what worked for this person, what worked for that person. And then we can start to get some sort of a strategy together. So the answer to why there's no major clinical trials, most of them are not done correctly because the people doing them don't have an understanding of the biochemistry that's underlying this. So I don't fault them because a lot of people themselves would like to be treated with metabolic therapy. The problem is that the practitioners, the physicians, don't always have the necessary background or understanding of what they are supposed to do, how to do it, and how to measure outcomes. We're in the process right now of writing a very comprehensive treatment protocol for managing glioblastoma, which is one of the most deadly and unmanageable cancers that we know about today. We have a very comprehensive strategy for managing this kind of a tumor. Can it be done? That's another thing. We have this tremendous treatment protocol for glioblastoma, but nobody will use it. And the answer is, how could that be? Because we have the science behind it. We know from preclinical research, from our preclinical research, that it will be very effective. We have individuals, case reports, knowing that it will be effective. Why can't it be used in like the major oncology centers? Because they need to have the standard of care done first. And I told them, I says, so you have to have the groups of people. Okay, we have one group of people get the standard of care. 90% of them are dead before 5 years, more. Okay, then we have metabolic therapy used with the standard of care. Okay, so we're starting to see these folks doing a little bit better than standard of care by itself. Well, where is metabolic therapy by itself without radiation and chemo? Can't do that. No, not allowed. Not allowed to be done at any of the major medical centers. The board, the IRB, Institutional Review Board, has nixed those kinds of studies.
Because they would say that you're harming the patient because you're not following what we've established to be the standard of care, which comes from the fact that, hey, cancer is a genetic disease, not a metabolic condition. right? Not a
Yeah.
metabolically
Yeah.
driven.
Well, it comes from the ideology, not only that cancer is a metabolic disease, but their complete lack of understanding of what their actual standard of care treatments are actually doing to contribute to the rapid growth of the tumor in the brain. So as I have published very clearly over and over again, when you irradiate somebody's brain with a tumor in it, you explode the amount of glutamine in that microenvironment, giving those tumor cells an absolute a bouquet of growth factors and fuels to grow out of control. So you create a mush in the brain. You give the patient high-dose steroids to control the swelling of the brain from the radiation heat. Steroids are like drinking Coca-Cola. They make your blood sugar go up to very high levels. So what are you doing? The very treatment that you're throwing at these poor folks is contributing to the recurrence and the death of the patients. And I've said that over and over again. Why there's so little survival for glioblastoma? In every major medical center in the world, it's so consistent that people are all dead before 40 months. Not all. You get very rare survivors occasionally. Almost everybody in 10 years is dead for sure. What are you doing? I said that's the worst thing you can possibly do to somebody with a brain tumor is irradiate them. And yet they continue to do it. And one has to say to these guys, what's wrong with you? What do you ignore the scientific evidence? What are you doing to these poor folks? I've clearly shown that that's what's creating the recurrence of the tumor and killing the patients. Why? Because it frees up massive amounts of the two fermentable fuels needed that's the science behind it. You got to understand the science behind what's going on. And it makes perfect sense why these folks are not surviving. They come, they look like they're doing well for a while, and then all of a sudden that tumor comes back like a raging bull, and the liquefaction of the brain from the radiation. It's just like, it's tragic. It's malpractice as far as I'm concerned, to do something like that. It'd be one thing if there wasn't any evidence. It'd be one thing to say, well, this is the best we can do. But when I publish evidence and I clearly show that treatment is responsible for the demise of the majority of these brain cancer patients, it's criminal to be doing something like this. I'm telling you, man, this is like nuts. And, people are saying that, it's hard to reproduce science. There's nothing, you should see how reproducible the death of the cancer patient is. You can't design better experiments for reproducibility than how fast standard of care kills GBM patients. That's terrible. Isn't that terrible to say something like that?
It's terrible.
Well, why don't the patient go look at the data in the literature? It's not coming from my mouth. It's coming from the data from the top medical schools.
Yeah. I mean, the audience, everybody listening here, they can feel your passion for what.
Well, when you see enough of this crazy shit for as long as I have, you say to yourself, "What am I going? Maybe I'm going nuts."
No. It's basically you're being, your work and research is being, the phrase is overused, but it's being gaslit by the medical profession. Many of them, again, under that sort of, this is the consensus. It's already been established. You can't question it. Until, unfortunately, we're in a situation where...
Jethro, why don't you get one of these guys from the top medical school and ask them, why the hell are you irradiating your patients? Don't you know it's killing them all? Go ask them that. See what kind of response you get.
Yeah,
you probably won't even want to come on your show.
They wouldn't want to come on, for sure.
Well, you got to ask them these questions, because I'm certainly asking them.
No, we do. It's important. And I think, like you said earlier, the groundswell is coming from the lay people who are interested in hearing directly from sources like yourself. This is why, podcasts around the world have really taken off, because people want to hear the full story, and they want to get a chance to decide if they want to investigate something, and they want to weigh the pros and cons of looking at stuff.
Here's the problem. I can say all this stuff because I have done the basic research myself. I have looked into the concepts. I have studied these concepts. The problem and the great tragedy is when the cancer patient with a glioblastoma, lung cancer, breast cancer, whatever it is, they go to the top medical schools and they tell them, I want metabolic therapy. And we can't do that here because there's no evidence that it works. So these poor folks are now, hear what I say. They get all fired up. They go down to the top medical school to say, I want metabolic therapy. Well, we don't do that here. Well, who does? I'm going to lose my license if I do that. What the hell is going on with that stuff? So I feel bad when they say, whoa, where's Seyfried's clinic? I don't have a clinic. I'm not an MD. I don't treat patients. Why are there no clinics? Well, because a lot of the folks that would need to be doing this could lose their license if they treat patients without the standard of care. So why is the standard of care written in granite? Why can't it be modified in some way where the medical schools, they should be the ones? Dana-Farber, MD Anderson, Sloan Kettering, the Moffitt, the Fred Hutch, all of these major cancer centers throughout the country should be the ones that are doing this. Why are they not doing it? That's the question.
The contrast between how traditional medicine looks at cancer and like how they understand it, and from Seyfried's point of view, how him and his colleagues, and there's other individuals that are in this space, but because we're mentioning him, what important truth, the Peter Thiel question, what important truth that he and you believe about cancer that very few others end up believing. Gregory, would you like to jump in?
So first off, most people, oncologists, they think that cancer stems from a mutation. And I think that it's pretty much proven that that's not the case, that the mutation that causes the cancer is actually downstream from mitochondrial dysfunction. And those studies, they're done and really conclusively proved that. So they transferred mitochondria, and they also transferred the nucleus of cell where the DNA, where the mutations would be. They transferred them back and forth, and they can prove that the damaged mitochondria are what driving cancer. So you have to think about it metabolically because the mitochondria make energy. So it's really and how we think about all disease states. And Hippocrates Research Foundation, I want to say a couple things. First, we took the name Hippocrates Research Foundation. First, do no harm. So everything we do, there's no harm, right? We're just making you stronger, better. And so we've even taken these metabolic therapies and use them in athletes, even professional athletes, to make them better. So when someone comes to us, we don't feel bad that we're going to hurt them. We're only going to make their life better. We're going to make them stronger. And so we're thinking about cancer as there's a microenvironment that sets up in your body, and that's pretty well established too. Cancer likes there's usually an infection involved, and I think that's pretty well understood, for certain H. pylori and human papillomavirus, for cervical cancer and these different things. So we're looking at cancer more as an environment that you have to change the person's chemistry. And long term, that's how you're going to keep them cancer free. So we're looking at it a different way. There's a lot of ways to just get rid of a tumor very quickly. And we're picking a way that is least toxic. But there's some really, and we can talk about later, but there's some really great things that, different immune therapies that really work great. And there's even a type of radiation that works great combined with what we're doing. So it's pretty easy to take even a stage 4 cancer and get it to go away. But then if you don't change the person's chemistry, let's say, lifestyle, the same environment that's set up for that cancer, it's going to come back. And so there almost has to be a new subset of oncology for the prevention, the long term. How do you keep people cancer free? Because they're all calling us, and they had initial success for a minute, maybe 6 months, but then it came back. They got another treatment. It came back. And then they're like, man, I can't, I'm so beat up, I can't do it. So they're coming to us. But at that point, it's almost sometimes too late, to do anything. So we're thinking about it, and we're starting things like, let's repair the mitochondria from day one. And how do you repair mitochondria? And we can get into that. So there's a guy named Garth Nicholson. He was a researcher at MD Anderson Hospital, and he coined the term membrane lipid replacement therapy. Every person with cancer should be starting to repair their mitochondria day one. So we're looking at it a little more holistically. Also, oncologists aren't looking for or treating the viruses associated. So like head and neck cancer, 80% of them have a certain type of virus, and but they're not treating the virus. So if they don't treat the virus, it's just going to come back. So there almost has to be the subset of oncology that's working to prevent. And so there's 18 million people that have been treated and living, and they think they're cancer free. But what we have done now is we follow circulating cancer stem cells, DNA fragments, and all these things that pick up cancer years before even the most sensitive test. You had a guest with Prenovo, and we like that company, right? They do some really great scans. So we send a lot of people to Prenovo. But
a full body MRI scan.
Yes. And they do other scans too. And but very, very sensitive. But with it's called a liquid biopsy, and that's kind of a generic term for circulating cancer stem cells, DNA fragments, and there's a lot of companies in this field doing that. So we want to, like, ideally, everyone would be doing one of these tests yearly. We don't have any skin in the game with the Grail test. That's a new one. But there's many of these tests, and they pick them up years before. That's what everyone needs to be doing. And now Michelle and I, we think experts, because we've kept quite a few people many years following circulating cancer stem cells. We keep them low, and statistically, we know a threshold. If they don't get past a certain point, you won't get a recurrence. So that's available to everyone today. But we need a group of healthcare providers that know that space, and they're just not there. Yeah, they're functional medicine people here, there. There's a few people know, of course, or these companies wouldn't be in business. But we need to make that more mainstream, make it available to everyone.
It's disjointed right now, and it has to be brought together a little bit to make it easier for the end consumer to be able to go through the process.
Well, it's the same thing. I think there's a lot of these companies, I'm sure they see an opportunity. Oh, here's an opportunity. It's a new test. We can find this. Yeah. Well, that's great. Now you found it. What are you going to do with that information? And then how are you going to use it to help the patient? And okay, so you've got a certain number of some circulating cancer stem cells or DNA fragments, but what do you do to keep that number low so it doesn't manifest itself as a tumor or a cancer?
Right. And Michelle, she, about the time that she was, we thought she had breast cancer, she started, for whatever reason, says, I'm going to do an Ironman, and which was, wow. And because she never swam, bike, or ran, I was like, good luck with that. And, and somehow she pulled it off, and I got involved, and I'd been using pulse electromagnetic fields, microcurrent. That's a whole nother crazy athletic performance field, and also with some medical applications, health applications. So we started doing that stuff for Michelle, and so she quickly, within a couple of years, there's a U.S. Ironman team. Michelle made that. Our family went to Motala, Sweden, watched her compete. That was really cool, and so what we're doing is only going to move people forward. There's nothing, there's no side effect with working with us. And so we're looking at it completely different. So we're just increasing everyone, their human existence, human performance. And so, pretty easy to work with us. And we're only hampered because there's just not many people to coach these people. And we can talk to Dennis more. We could write it all down we could write it within 10 pages. We could write exactly what to do, but people won't follow it. It is crazy.
Well, it's difficult. And I think it's a good opportunity to get into the protocol, but leading up to, back to your story, do you prefer Dennis or Den? Den. So Den, going back to your story, and now with your family on board, you mentioned about the support of your wife, your children, especially your older son, saying, look, your situation's a little bit easier in a way, if I could say, because you're being given choices. There are no choices. What did you do from there, and how did the two of you connect?
Well, I think, long story short, there was a deep dive into Seyfried's work, the published work, his book, which anybody that's going through this or is listening to this and is thinking, where do I begin? Pick up Seyfried's book, Cancer is a Metabolic Disease, and begin to meticulously study it, because everything you need to know about whether or not this is makes any sense, how to do it, all of the proofs, it's all there in glorious detail. So I started there. I went through the papers. I watched hours and hours of videos. So, let me just stop and say thank you for, doing interviews with Seyfried and everybody else that has, because for a lot of people, that's where they find the door to this. And in your darker hours, when you're wondering, am I doing something that makes any sense at all? Going back to those videos and listening to him speak, and with the certainty that he states the things that he does, it's just really wonderful. But so we began diving into all of this. I was reading, paper after paper after paper, book after book, sometimes, several papers in a book in a day, because there's some sense of urgency too. When somebody puts a stopwatch on your life, you get focused.
There's no time for Netflix and shit.
No, that's right. That's right. So, that's what we began to do. And so you start to put together questions like, okay, well, I'm seeing here that I get that we need to, lower glucose into a therapeutic range, but there's this murky bit of business here about inhibiting glutaminylysis and glutamine. And well, what are we going to do that? How is that done? You start to dig. And so I had some questions, and I wrote to Seyfried and I said, this is who I am. This is what's going on. I'm reading your stuff. What can you help me with? And he's very busy and very much like the Howards. He's not taking people on as a doctor. He's not prescribing anything. So what you get back to tends to be a package of information, which gives you a kind of another 30,000 foot view of some specifics. And so we digested that. And then I got very specific with some questions, and I asked something about, I think, the difference in efficacy between oxoacetate and 6-deazo-5-oxo-L-norleucine, or DON. And at that point, I think he just got sick of my emails and sent back an email that just said, call Daniel Orrego and a phone number. And so I did. And Daniel immediately picked up and said, what's going on? And I told him, and he said, you've reached the right place. Let's go.
Well, Daniel, you and I caught up for coffee
recently.
And one of the things that I remember you sharing is that, you get dozens and dozens of calls every week. And what is because of the stage of where the support system and the education for people in dense situation is, in terms of, you guys clearly have the protocol broken down. You know what works, and you know how to adjust it, or at least give recommendations on how people can adjust it to follow Seyfried's work. But one of the first things you mentioned is that if you don't understand the fundamentals, you are getting started on the wrong foot. And one of the most fundamental things is understanding that this protocol and adherence to it takes a precision level individual. And you mentioned to me that you almost find more compliance from individuals that have a little bit more of a bodybuilder approach, where they're like used to measuring every calorie, practicing something, testing multiple times a day, their glucose. Like, it takes a certain type of person to really know that they're going to be able to walk through the specifics of following through with this protocol.
Yeah. I mean, well, you're sort of alluding to, if there's any weakness to metabolic therapies in general, and specifically to the press pulse protocol, is how much is required of the patient, right? In terms of independent self-administration, right? The burden is on them to execute effectively on what the protocol requires, right? So that's something that's just worth acknowledging. For people who are accustomed to measuring things, yes, it does constitute an advantage, to be sure. And, I think that's one of the areas where sometimes people have a concept that, like, okay, I do this magical diet and somehow that does good things. And then I do some other magical drugs and that does some other things, and then I'm good to go. And, one of the things that, it's a somber thing to have to acknowledge, but there's no silver bullets in cancer. There's bullets, there's just no silver bullets. And so, the ability to be very consistent over time constitutes an immense advantage, which is basically maybe a roundabout way of saying being able to do the same boring thing every day, week after week, month after month, to produce a very specific effect on metabolism. And this primarily starts with the very precise control of daily fat grams, protein grams and carbohydrate grams correspondent to at least twice daily measurement of blood glucose and blood ketones pursuant to validating if, in fact, glucose is in the 55 to 65 milligrams per deciliter range, or 3.0 to 3.5 millimolar if you're using that scale. And is that happening every day? Is that being achieved on average over a week, over a month? Are the standard deviations somewhere below 1 or below 0.5? These are the things that must not only be understood and appreciated, but be applied. And that sort of goes back to what Dennis mentioned earlier, which is starting with Seyfried's book is so valuable.
That's the first step for
it's
anybody.
So valuable because it's a foundational work, but the details are in there, not only in the references, but in what he's contributed to the field insofar as providing the data which demonstrates, look, if you want to produce these effects, these are the things that must be achieved, not today, not tomorrow. This isn't a weekend project, month after month, consistently. And that is daunting for a lot of people to have to face, because oftentimes, people are under the impression that it's like there's a diet that does something.
Yeah, a lot of people watch the interview that I did with Seyfried
Yeah.
and are like, oh, I get it. You go on the ketogenic diet,
Yeah.
you cut out some sugar.
Right. Yeah. I
And-
don't eat any sugar, largely immaterial. The question is always, what are your glucose and ketones today? And what have they averaged in the last week? And exactly how many grams of fat, grams of protein, and grams of carb are being consumed on a given day? That's the litmus test. In other words, if somebody can answer those questions cogently, you can have pretty high confidence that they are pursuing press pulse protocol with the required level of specificity and precision to extract a clinically measurable result, because that's what we're looking for. In other words, with cancer, the proof is very much in the pudding. If the result doesn't show up on the PET CT scan, then what can you say you have achieved? Right? Very important.
Den came into the conversation having done probably a decent more research than most individuals who
Yeah,
come across
he came equipped. He came equipped. Yes.
Right? He came equipped. And as he had mentioned, didn't have a lot of time on his side. So needed to come equipped. For the people that are listening now who maybe caught part of our Seyfried interview, or maybe they're watching this for the first time, I'd love to explain to you just high level, the way that I've been sharing the pulse press protocol with people who ask, not having been in all the details that are there, but just to give them some sense that first and foremost, diet is not everything, and yet diet is the foundation. That's one of the first things that I've understood, in the sense that this isn't about cutting out some Mars bars. This isn't about not having sugar or adding some sugar to your Starbucks. This is about fundamentally maintaining a precision level of blood glucose within a very specific range. Because when you do that, it essentially, in layman's terms, puts the cancer in a situation, not on its own, it's one part of it. It puts the cancer in a more vulnerable position. Without that, none of the other things, as we get into them, drugs, hyperbaric, additional items that might be there, nothing else can actually have a chance to press upon the cancer or sort of target the cancer if the cancer constantly has its primary fuel sources. Exactly. So that's the dietary intervention, right? Is that it's way beyond our understanding of keto. It's way beyond our understanding of, this diet or that diet or other things. And it's also has some themes and kind of rhymes a little bit with fasting and fasting mimicking diets. But in the sense, it's different because if you keep fasting at some point in time, you'll die. And so you'll die of that.
We call that starvation.
That's called starvation.
Yeah.
So you can't long-term extreme fast. So you need to have something that essentially mimics fasting. And fundamentally, the diet as part of the Seyfried protocol is that. It's sort of creating these conditions that are sort of similar to a long-term fast that's there. Now,
but it has and Daniel just stresses this so much. You still have to supply fuel for your body.
Right,
because
your body still needs things.
Right, you don't want the muscle breakdown because, again, just like what Greg was saying is you're trying to make your body healthy so that it can fight the cancer too. And so that's what's so important about the fat, the protein, exactly what Dan and Daniel and Dan are talking to people about is it's so important that you're still supplying the right nutrients for your body. It's not just, let me starve myself and this is going to fix it all.
Absolutely. Yes. You need to support the muscle mass in the body. You need to support all the different organ systems. Yep. So in one way, you're doing the things to starve the cancer, again, quote unquote, starve the cancer. But in another way, you're rebuilding the body as well too, and supplying the body.
We look at a lot of different, usually they just look at tumor markers. That's kind of interesting. We don't really look at tumor markers that closely. We wait, but we just for to educate ourselves, we're looking at a lot of other things like the amount of inflammation. So we know if someone has a high C-reactive protein, that's a non-specific inflammatory marker, or start with diabetes. All these things are risk factors. So we want to fix that along the way. So even though it takes some period of time, they're fixing their chemistry along the way. So then they're not going to get a recurrence. So Dan hasn't implemented some of the things that, so he's about 6 months post-cancer, hasn't had a recurrence. And I don't think he will because he's changed his chemistry and he's still eating the same way. So when you look at things like CRP and different immune markers, everything is fixed. And so it's got to take, we want to get this process down to a month or two, but really maybe that's not a long enough time because we haven't fixed their whole body chemistry. So it would just, we wouldn't be any different. We would be less toxic, but no different than using some other standard of care because it's too short. We haven't fixed their body chemistry and it would just come back.
Daniel, going back to you, once you two had the conversation and you understood his background, his story, how prepared Dan was coming into it, his motivation, his will to want to survive. How did you, and I think it's important for people to understand, the Hippocrates Research Foundation, you guys right now, you don't charge for these things. This is something that you're doing. Both we want people to donate to you, right? And so anybody who's listening today, please support the foundation in its work to provide more support to individuals and to eventually, of course, do any other further research that you guys want to do. But essentially, you guys are there as a resource and a guidance to individuals. Is that accurate to say?
Yeah, that is accurate. And one of the things that Michelle and Greg and I talked about in the beginning was we understood that having a fee-for-service model just encumbers the process of being able to interact with people in a way that makes sense for them. And so that's why we establish Hippocrates Research Foundation as a not-for-profit philanthropic organization, because given that we're a small working group, that would allow us to preferentialize our time to people that displayed the most interest, the most inclination, and the most dedication to pursuing Dr. Seyfried's Press Pulse protocol. So that was quite a conscious thing when we started. Because we knew that, our time is limited, right? We're 3 humans, 4 humans, 5 humans, 6 humans. And so we understood that, having a framework that would allow us to operate in an entirely egalitarian manner, driven by people's interests, would actually allow us the ability to produce the best results. And so that was, I think, something that was foundational to the relationship between Dan and I, and the relationship between HRF and anyone that we work with, is if they call, we'll just pick up the phone and say, okay, how can we help you today? And then based on their interest, we let that drive the interaction. And so we know that the people who are incessantly bugging us are the ones we have to worry the least about. And the reason for that is because they are meticulously obsessed with every detail about what's going on with them. And that was very much the character and nature of Dennis's and I's relationship and interaction. He would call and be like, okay, what's going on today? All right, let's get into it. Let's read these papers. Let's go back and talk about things that we talked about before, but now more deeply. Let's re-explore things that perhaps were working at a certain period of time, but now aren't quite working in the same way, and try to understand where the adjustments have to be made. So this was a high interaction, high touch back and forth. And that, led us to understand that, his ability to have success with this process was going to be elevated because no detail was left unexplored. And many details were re-explored any number of times. And ultimately, that's how you learn. And that's how we learned. In other words, in the beginning of this process, if guys like, Peter Attia and Dominic D'Agostino and Dr. Seyfried hadn't been indulgent with us in answering the same question the 30th time, or giving us another opportunity to interact with them and to pick their brain about things, how could we have learned? Right? So there's a little bit of a pay it forward component to that, because they've been so generous and so indulgent with us. And we realized, okay, that was what gave us an effective means of really understanding this work. And it's the same form of interaction that we have with all the people who are having success with this process.
Yeah, that's it's really important. My interaction with Daniel and with HRF hasn't been transactional, in that I'm having a particular problem today with trying to figure out some issue with the paper I'm reading, and I call Daniel and he's like, oh, here's the answer. It's never been that way. In the email to you, I said who was a mentor and who became a friend. And I mean that in its purest form. When you call with a question, I know that Daniel knows the answer, and he could very easily, in less than a minute, simply say, oh, the thing you're looking for is this, you find it here, this is what it means, but that isn't the interaction you end up with. The thing that's special about HRF and about Daniel and the Howards is that they're dedicated to developing mastery in you. So, of course, they've mastered this subject matter, but for you to be able to get well and to stay well, and hopefully to help other people get well, and to do that, as Daniel says, week after week, month after month, year after year, to stay cancer-free, this material has to be deeply understood. And the interaction you have with them is one of mentorship. Oh, that's an interesting question. How are you going to answer it? And it's extraordinarily effective. You come out the other side an expert in your own disease management, and ultimately resolution.
So Dan, one of the things that people didn't get from the Dr. Seyfried interview that we did was they didn't get sort of, let's say we're at 30,000 feet above a view of like cancer as a metabolic disease, metabolic and mitochondria disease. You go a little bit further down and you're like, okay, what are you actually doing on this thing?
Sure.
Right. Yeah. And I'm sure you have to explain it to your kids, they see you. So before we go deeper into the weeds here and some of the, finer sort of tweaks and the ins and outs, how would you describe the protocol as you understood it to people around you who didn't come from a science background and hadn't read all of Seyfried's work?
Yeah, I think that the easiest way, without getting into the weeds at all, which these guys are much more qualified to do in a much more articulate way, is just to understand that what we now understand is that cancer has two fundamental fuel sources. Cancer ferments glucose and glutamine. And so just about anybody of any age, if you tell them this fact and say, well, what do you think we should do about it? Most of them will immediately say, well, why don't we take away those fuel sources? Everything that a cancer cell has to do, make cell membranes, divide, spread, everything that happens is entirely dependent on access to its fuel source. Energy metabolism drives every other part of that. And so, number one, you have to inhibit these two fuel sources. What are they? Well, they're glucose and they're glutamine. So the first part of the protocol is figuring out exactly how far you've got to lower glucose and exactly how often and how far you've got to limit glutamine to take away the two fuels that drive cancer growth, spread, metastasis, and everything that it wants to do every day.
And so I'll jump in. So a lot of people don't know the source of glutamine. Glutamine is your amino acid that makes your muscle. So we need glutamine.
Right. It's a healthy part of the body.
It's a healthy part of the body. So that's why Dennis is kind of a big guy. He's got a lot of muscle on him. So when we're inhibiting glutamine and glucose, you're going to lose some weight and you're also going to lose some muscle. So we can't really start with someone that's emaciated with no muscle. There's no place to go with that. So he was really, everything about his case was perfect for us. You know, he hadn't had chemo radiation, so he wasn't all beat up. He had some weight and muscle that we could, you know, wasn't going to hurt him to take that down a little bit. And so, yeah, he was perfect. And, but that's the fundamental, glucose and glutamine. And then everything else kind of stems from that.
Yeah. And to add to that, as Daniel's pointing out, by very carefully and meticulously measuring fat grams, protein grams, and carb grams, you can use food as a drug to manipulate metabolism such that your blood glucose drops into a therapeutic range, which is 55 to 65 mg/dL. But with glutamine, as you're pointing out, it's this very important thing. It's used in 121 processes in the body. Your immune system relies on it, which is a very important part of healing from cancer. Your gut biome and your GI tract rely on it. So it's not something that you can day after day, hour after hour inhibit. This is where the name press pulse comes from. We press on cancer by limiting access to glucose, and we do that in a sustained way, creating metabolic stress. And then we pulse in instances where at specific times and in specific ways and in combination with other parts of the protocol, like HPOT and the use of other substrates, we inhibit glutamine just for a few hours using whatever method we do. In my case, it was a drug called Dawn. And that allows you to safely remove glutamine from the equation for just long enough to create a problem for cancer.
On a daily basis, just to add to what you were sharing, and this is part of the meticulously following the protocol, you know, we're all sitting here. I didn't really eat breakfast this morning intentionally. I fasted. I do wear a continuous glucose monitor. I don't have one on today, but if I probably would check finger prick or continuous glucose monitor, I know me right about this time, I'm probably my glucose is somewhere around the range of maybe like high 70s, low 80s.
Sure.
You know, just because I generally have a good, you know, metabolic health and everything. You know, the level that you are needing to get your glucose in, as you mentioned, is beyond sort of what would be normally considered a healthy range.
That's right.
Right. And it's to get into this therapeutic range.
Right.
And as I understand it, you want to keep it there for a long period of time.
For as long as it takes.
So that means that you are twice a day, again, following the Seyfried protocol. And Daniel, you and your team were doing this with dogs initially,
Yep.
right? That had cancer. Twice a day, you're checking in using a finger prick test to see, are you within range?
That's right. And I mean, when you're really getting into it and you're really trying to find your stride, I mean, sometimes you're going through 8 test strips a day. Like you're trying everything you can to really get a handle on how your body's responding and what you're doing and whether this type of food is having an impact on blood glucose. So eventually near the end, yeah, you can get away with 1 or 2, but I was testing quite a bit. Yeah.
And it's not just, Dr. Howard, it was not just the food component that plays in. A big part of Seyfried's protocol is also making sure that you significantly reduce the stress component in your life. Why is that so key?
Well, so Dennis, he told us something that we didn't know. Apparently, if you play some video game, you can raise your blood sugar 50 points and it'll stay there.
Yeah, it's a funny story.
It's a micro stressor. Your blood glucose goes up.
Well, you know, Seyfried's protocol very specifically in that 2017 paper, it very specifically says, you know, stress reduction, mindfulness, meditation, these are things that you know, we know Seyfried, this isn't just an afterthought add-in. It's critical. It turns out that stress causes your body to produce cortisol, the stress hormone, and cortisol drives something called gluconeogenesis, which is the manufacturing of new sugar, new glucose in your liver. And so if you're not managing your stressors, that can be job stress or child stress or any manner of stressor, your body, you know, if you get even a little bug or a little cold, you'll notice, especially when you're in these very rarefied ranges of blood glucose in the therapeutic range, you'll notice these sudden changes. And so Dr. Howard's actually referring to this very funny story where a friend of mine knew I was sort of at home, holed up, trying to heal, wasn't able to see people, and he thought he would be very helpful. Thank you very much, Jay. And went out and bought a PS5 so that we could play PS5 golf together. But it was a ruse. He really wanted to play this game called Warzone, which is this very aggressive, high-speed, high-octane game. And so I agreed that I would play around with him. And at the end of a few hours of this game, I went from my blood glucose at 62 to blood glucose at 120, where it stayed for almost an entire day. And this is just illustrative of the fact that external stresses drove blood glucose production in the liver just from a game. It's at these ranges where you're trying to maintain blood glucose, stress management is critical. So dealing with family stress, dealing with work colleague stress, dealing with child stress, dealing with anything that's going to upset that apple cart is critical.
And even we noticed with Michelle, she works out like 3 hours a day for the Ironman, and that will raise your blood sugar while you're doing it. And maybe after like 3 hours, it'll start to come down, but she might be at 60 or 70. And then when she's running, it'll be 110 and it'll stay pretty constant. And so, yeah, a lot of people, it's interesting with the, they're taking sugar and goos and all these things while they're running a marathon. Well, your sugar's already pretty high, and that probably doesn't do anything. Might give you a little sugar rush, dopamine release, so you feel better, but metabolically, are you making yourself faster? No, probably not. You already got enough fuel already.
So just adding to this sort of view for somebody who's following along and they're like, okay, I'm trying to piece together exactly what he did and how he's in this situation. So there's a dietary piece. There's a strict adherence to keeping your blood sugar within range. And there's also this other piece, which is, we talked about the stress piece. And then every so often you're going and doing hyperbaric.
Yeah.
Let's talk about that.
Which is, I mean, it's phenomenally interesting. Not enough is said about HPOT in many different disease models, but in cancer, it's extraordinarily interesting. Daniel was mentioning a scientist earlier, Dom D'Agostino, who did some phenomenal work on this and was able to show with a probing electron microscope inside a hyperbaric oxygen chamber, glioblastoma cells tearing themselves apart because of reactive oxygen species at, I think, 2.5 to 2.8 atmospheres absolute. So when you get into a hyperbaric oxygen chamber,
a hard chamber, there's soft chambers, there's hard chambers.
Yeah, the soft chambers are, they're great for all kinds of things. They have their own benefit and their own use. But for cancer, when we're telling people to get HBOT therapy in conjunction with a pressed pulse, we need the hard chambers because they can go to these depths. And while you're in a hyperbaric oxygen chamber at depths above 2.2 to 2.8 atmospheres, what happens is reactive oxygen species act very much like radiation therapy does to tear up cancer cells. Radiation therapy is effectively knocking an electron off an oxygen molecule, and it's causing a dysregulated spin that flies around and tears up the cancer cell. Well, you're doing the same thing with oxygen, but radiation isn't preferentially targeting a cancer cell. It's doing that to every cell in the immediate vicinity. What we found is that hyperbaric oxygen, largely because the rest of the body has protection from the ketone bodies that are being burned in the cells, you get the same effect as radiation from reactive oxygen species generated in hyperbaric oxygen at those depths and pressures.
And how often are you going and in the protocol?
Yeah, Seyfried calls for going 5 days a week. It can be a little bit cost prohibitive. For me, I couldn't afford the time or the treasure to go 5 times a week, but we were able to figure out 3 times a week. And so for the entire duration of all the protocols, which we break up, so we have we probably did 4 protocols in total over 6 months. For the entire time, we'd be going three days a week, making sure that one of those days you've got your substrates on board, your blood glucose low, your dawn on board, and you're in hyperbarics. And that's a very powerful cancer killing moment.
We just want to be minimizing our exposure to these chemicals that are coming out of our plastics as much as possible.
Let's zoom out a little bit big picture, because we know that some of these plastics and the broader topic of environmental toxins, that there is some links to some of them being connected to, things like cancers in the environment, right? Yeah. In fact, you had a great post just a few days ago. I took a screenshot of it. I'll have our team put it up on here so that people can watch it on YouTube. In that post, you wrote, "Cancer is one of the leading causes of death, yet evidence suggests that lifestyle modifications can prevent 30 to 50% of all cancer cases." I don't think that most people know that statistic, right? No. 30 to 50%. Obviously, it's much broader than just plastics. We're talking about lifestyle habits, exercise, which has a lot of demonstrated ability to help us prevent cancer, being metabolically healthy. But of course, the environmental toxins conversation also plays into this. Do you want to talk about that too?
Yeah, absolutely. I mean, to your point, only a small percentage of cancers have a genetic component. And when we know that the remaining cancers are environmental. And to your point, environmental means not just chemical exposures. It means, do you smoke? What's your metabolic health? All those things. And we know that those are preventable. And even with the genetic component, we do know through the field of epigenetics that we can sort of dampen some of the expression of those genes associated with disease by modifying our lifestyle. So doing all of the, very typical eating well, sleeping, managing your stress, all those things are sort of generic health guidelines. We know that can sort of dampen the expression of some of these cancer-associated genes. So lots of reasons to adopt a healthy lifestyle. But the toxic chemical component is, I think, just overlooked. There are so many different exposures to carcinogens that we get. There's also exposures to chemicals that aren't directly classified as carcinogens, but can have downstream consequences that can lead to cancers as a result. So, for example, prenatal phthalate exposure. Phthalates are, again, that plasticizer. They're an endocrine disrupting chemical. Prenatal phthalate exposure and exposure as a young child for girls can introduce their body to these synthetic estrogens, which phthalates can behave like a synthetic estrogen for a long period of time. And we certainly know that a woman's lifetime exposure to estrogen is directly related to her risk of developing breast cancer. And the more years that she has exposure to estrogen or synthetic estrogen, because our bodies cannot tell the difference, the greater the risk of her developing breast cancer in the future. So there are things like that where phthalates aren't classified as a carcinogen per se, but we do have evidence of downstream cancer-related consequences. And I think that's, there's 350,000 chemicals and chemical mixtures registered for use around the globe. This a recent number, I think from 2021 analysis that was 3 times the previous estimates, meaning we don't really know what is going on globally. And we're only just being hey, maybe we should pay attention to this. It's kind of gotten out of hand, right? So, I think I'm from New England, so I always think of analogies in the fall when you're trying to rake leaves and the big gust of wind blows and it's just I feel like this is us chasing individual leaves that are just blowing all over the place, untethered, unregulated, uncontrolled. And we're just we're picking up this leaf and going, is this leaf okay? Meanwhile, there's a tsunami of leaves behind us, right? So we just have this sort of flawed approach. So there's these massive quantity of toxic chemicals, or I should say chemicals. We don't know if they're all toxic. Certainly many of them are not, that are in commerce. And we know that toxic chemicals specifically touch every single organ system in the body. No tissue is spared from some downstream consequence of those exposures. And we're still learning what those consequences are. And so cancer is absolutely going to be on that list of endpoints for a lot of the chemicals that we are exposed to on a daily basis.
On the topic of cancer, you shared an incredible post just the other day featuring a new study showing that 921 chemicals are linked to breast cancer, which is, first of all, mind-blowing, right? And all this, every week, there's a new headline, nanoplastics in bottled water. That was one that recently came out. Every year, we're learning more and more. And this is all showcasing the idea that even though people in the industry say that, hey, look, these things are regulated, they're safe, the truth is, and this is what you're trying to highlight through your work, is that we actually don't know, primarily because there's no long-term studies. That's one thing. But then there's something else, which is called the cocktail effect that you talk about. Can you talk about the cocktail effect and how it really shines a light of why we as consumers need to be proactive about the combination of all these things? I've talked to countless experts, skincare specialists, and even plastic surgeons who all tell me that red light therapy is one of the best therapies we can use on our skin. And my favorite red light device is Lumebox. I love Lumebox because number one, it's portable and simple to use. Number two, it's FDA registered. And number three, best of all, it's affordable. Personally, red light therapy has helped me improve the appearance of my skin. It's also helped me with muscle and pain recovery. And red light therapy has also been shown to improve multiple studies on inflammation, wound healing, hair, and it's even been shown to stimulate our mitochondria. I use this device every single night before bed, and it's the perfect way to wind down. I swear it's helped me sleep better. Right now, Lumebox is offering my community $260 off their portable red light device. That's over 50% off. Just go to thelumebox.com/Drew to get your device. I know you're going to love it.
Yeah, so I'll just back up to contextualize. So the vast majority of the time, when chemicals are studied, they're studied in isolation. And this is just because the less number of variables in any type of experiment or study, the easier it is to translate the data, because it's very clear that there's just this one component. And so the vast majority of research that we have on most things, but certainly on chemicals and chemical exposure, are happening on single chemicals. What happens if I give rodents, because we don't test chemicals on people. Historically, there have been some incidences of this, which are not good, but as a general rule in ethics, we don't test chemicals directly on people. I do have an interesting study I can share with you if you remind me that we did and got some interesting results. But as a general rule, we don't test chemicals on people. We use animal models for that. And then there's also some computer modeling that we can use. And so what we're looking at in rodent studies is, oftentimes they're really, really high doses of exposure. They're just trying to ascertain like, hey, what is happening here? And ideally, if it's a well-constructed study, researchers are also exploring what are referred to as background exposures or environmentally relevant exposures, which are really just parallels to what humans are getting just by living our normal everyday lives. Like the levels of chemicals that are showing up in us, researchers are now starting to examine those levels in rodents, in other animal models. And so we look at the animal model research and we draw some conclusions, and we hopefully will figure out what is the mechanism here? How is this exposure causing metabolic disease or cardiovascular disease? And then we look in human epidemiological data, which is just population-wide studies of people. And we say, hey, let's see how much PFAS or how much bisphenols or how much phthalates are showing up in the population, and what are the associations to these various health effects. And oftentimes what we're seeing is an exact mirror or a very close mirror in human populations of what we know to be true in animal models. And this is the way that science is conducted in this arena. And so, yes, there are going to be people out there that are still kind of poo-pooing this whole topic and kind of not taking it seriously enough. But the reality is that we now have decades, 40, 50 plus years of studies. And like you said, the volume of studies coming out is increasing exponentially for folks who are PubMed literate. They want to go into PubMed, search for, say, endocrine disrupting chemicals, and PubMed will show you a timeline of studies that kind of are flagged by that keyword search. And it's like this, the graph just goes whoosh, sky high because the volume of research has just escalated because people are learning more and they're more aware. And so all of this, going back to your question about the cocktail effect, is now we're starting to see, okay, what happens, or can we do research that might reflect, again, that exposome, the totality of our exposures? And we're starting that process by looking at what is referred to as the cocktail effect, which is specifically when we are exposed to multiple chemicals at the same time, which is the reality. How do those chemicals interact in the body with each other and with our physiology? And that's much harder research to do, but we are learning, for example, that with endocrine disrupting chemicals, the chemicals that can alter and interfere with our hormones, is that the effect of exposure to multiple endocrine disrupting chemicals at the same time can be amplifying. So 1 + 1 may not equal 2. 1 + 1 might equal 5 or 10, meaning when we're exposed to multiple of these endocrine disrupting chemicals, the effect can be way more amplified. And we can't just make these general assumptions that 1 + 1 equals 2 in these situations. And this is, again, why I think it's so important that as a species, frankly, in the absence of more strict federal regulations around the world, because I'm not going to wait for that to happen, that wheels of progress move incredibly slowly. In the absence of federal regulations, the onus does really fall on the shoulders of the consumer to be as proactive as possible. And again, the goal is to reduce as many of those exposures that we're getting in as many places as possible, while also, like, being a human being on the earth and not trying to. This is where I usually use the plastic bubble joke. I think of like the bubble boy from Seinfeld. But like for me, the plastic bubble joke is like, well, what kind of plastic is it? And is the plastic off-gassing? Ha ha ha. But, like, we can't live in that bubble. We have to live in the world. And to my point earlier about like people getting really stressed out and anxious, is we want to find the balance between taking action and being proactive, minimizing our exposure, and then also not amping up our own anxiety and stress and panic, because stress is also toxic. Stress is also incredibly detrimental to our overall health. So it is a balance. Yeah. It's an important balance. And I think, like we said before we started recording, I think a lot of the conversation on social media in particular is not balanced, and it's causing anxiety. It's causing panic. And that's not it for me, at least.
And yeah, and that's exactly what we want this conversation to be today. We don't want it to add to the anxiety. We want it to take away from the anxiety, knowing that there's a lot of solutions. On the topic of plastics, what are the main sources that you see every day when you walk into somebody's home and they ask you, hey, what should I be removing? Again, going room to room and we're in the kitchen. What are the things that people can make easy swaps for in their home? And what are the key ways of using especially these lighter plastics in the home that we want to greatly minimize?
Yeah, I mean, I think we just want to start with food storage. What are we storing our leftovers in? That's really easy. And we just want to move to a glass container. 10 years ago, 10, 12 years ago, when I first started doing this work, the only glass containers I could find were like ball mason jars, which are great. I have a whole cupboard filled with like dozens and dozens of mason jars. They make great storage. They're inexpensive. Target sells them. Walmart sells them. Hardware stores sell them. They're really accessible. Now there's more and more on the shelf at all these big box stores, on Amazon, wherever you want to order from, glass food storage containers. Some of them are going to have a plastic lid. And that's okay. My recommendation there, just again, from a practical perspective, is just don't fill it up so that your food's touching the lid. That's all. Just leave a little bit of space so that your food isn't directly touching the plastic lid. That's going to be a better solution. But these are really inexpensive. And, for people that might be on a really restrictive budget, reuse a glass pickle jar or a glass pasta sauce jar. Like I did that, 15 years ago. That's what I was doing. I just saved all my jam jars and put all my leftovers in those types of jars. So there are more accessible options, but, a case of, a dozen quart-sized mason jars is like $15. So, just over $1 a jar is a really inexpensive and really versatile way to swap out plastics when it comes to putting our leftovers in. And then the number 2 thing is, the plastic plates and cups, especially for kids, they don't need those. You can get stainless steel plates if people are concerned about breakage. You can get, there are some companies that make, I'm blanking on the name of it right now, that make like the borosilicate glass plates that are like pretty shatterproof. Like you can chuck it across. I know because I'm a little bit clumsy and I've dropped them myself a number of times, and I have those and they just bounce. And so there are safer options that are inexpensive that aren't plastic. I see a lot of people that have kids where they have plastic drink cups, plastic plates and bowls, plastic utensils. I think that's just an unnecessary exposure. Children are the most vulnerable when it comes to toxic exposures because their bodies are still developing. And so we want to prioritize minimizing exposures for them. This is also true for anybody that's pregnant in the preconception planning space. Like that is the most vulnerable population. So the things that we eat and drink on in terms of plastic containers, as an exercise, I encourage people who are maybe just starting on this journey to go into their kitchens and just open up all the cabinets. You don't have to do anything. Just like open the drawers and cabinets and observe how much is plastic. Is your pasta strainer plastic? Are your mixing bowls plastic? Are all of your cooking utensils, those black nylon, cheap plastic utensils that melt if you leave them in the pan too much? And just start making a mental checklist of like, okay, what are the items that I use the most? And just start swapping those out with better materials, stainless steel, glass, for dishware, ceramic instead of plastic. Metal utensils are totally fine to use if you're not using a nonstick cookware, which hopefully you're not, right? And so that's really sort of step 2 in the process, is just eliminating the plastics that you're using. Step 3, which is a little bit harder and certainly comes with a degree of privilege, is looking for foods when you're grocery shopping that are preferentially packaged in glass over plastic. So that means ketchup comes in a glass jar. Your sauerkraut is packaged in glass versus plastic. This is sort of the extra step. And I also, want to be clear that just for the sake, I'll use as an example, like sauerkraut or fermented foods. Like we know those are super beneficial to our health. We want people to be eating more fermented foods. And if the only type of fermented food that somebody has access to, either because that's what their store sells or what their budget allows, comes in plastic, still eat the sauerkraut. Like still eat the fermented food, right? This is not a race or a competition to perfection. This is also something that I see parroted a lot on social, is the sort of positioning of health as something that only like affluent people have access to. And I have a real problem with that because the people that are most disproportionately exposed to toxic chemicals are people that are lower income, that are Black or brown and living in disadvantaged communities. They often have those higher exposures. So a big part of doing this work and having this conversation is to make accessible recommendations. And again, keep that sort of balanced thread. But yeah, so get rid of your plastic food storage containers, then look at all the plastic items in your home and start phasing those out. If that happens over time, if that takes 6 months or a year for people to kind of work through that process, fine. The important thing to remember when it comes to these toxic exposures that we're getting every day is that it's the long-term exposure that matters more than our short-term exposure. So it's okay if you have to keep using the plastics that you have for the next month or 6 months. When we're looking at multiple years of exposure and use, that's where the kind of red flags come up.
That's great. And what a great reminder. On the topic of plastics, there's this whole category that you've written about extensively. And it's the plastics that are a part of our normal day-to-day life that actually make it easier to do things. And when it comes to the kitchen, they're going to be things like blenders, food processors, etc. You had this great post recently. I'll share it on the screen over here. It's called "What to Do About the Plastics We Can't Avoid." And slight spoiler alert, there are things that we can do because these tools, these things that we use, obviously plastics have made the world a better place in many aspects of life. Yeah. One being, ease of use in sort of the kitchen. In the medical field, of course, we're super reliant on plastics, but again, it's about minimizing our direct exposure. So when it comes to these plastics that we can avoid, the blender, the food processor that are there, what's most important for people to know? And then what are the suggestions and recommendations you have?
Yeah, I think the most important thing that I would encourage people to remember is the things that increase the rate at which chemicals migrate out. So that's heat, oil, acidity, abrasion. So let's talk about a food processor and something like a high-speed Vitamix, Blendtec, whatever, these multiple $100 blenders. First of all, if you're spending multiples of hundreds of dollars on a blender, you're probably somebody who's a foodie, who is interested in health. You're not throwing, ho-hos and Twinkies in a blender and calling it a gourmet soup. So you're not putting junk food in these high price point blenders. And so we still want to use these kitchen appliances if it helps to facilitate cooking at home, which is a great way to minimize exposure to PFAS, for example, and other chemicals, because we have more control. And so we still want to use these, but we want to consider heat, oil, acidity, and abrasion. And so if we're looking at grinding nuts or grinding something that's hard and abrasive, that is something that, we might want to consider. Just, you don't have to not do it, just be aware of it. I think the thing that we don't want to do, and I see this a lot, is don't go making your bulletproof coffee in your blender. Don't go putting a hot coffee with fat, that's heat and oil, in your blender and blending it up and then drinking it. You don't need to do that. You can buy a really inexpensive, immersion coffee frother. They cost less than $10. Coffee shops use these to just put a nice froth on your coffee. A simple switch like that. Similarly, if you're making a pureed soup, don't put hot soup into your blender. Either let the soup cool or use a stainless steel immersion blender. These are $20 or $30. So we just want to avoid using, and I think using those types of appliances like a plastic blender and a plastic food processor in that way. So for example, I love pesto. I make pesto a lot. I will use my food processor to grind the pine nuts and the garlic and the basil. But when it comes to putting the olive oil in, I actually will scrape the food processor bowl, move it into another bowl, and then I'll add the olive oil because I just don't need, it's just unnecessary. Also, it makes your cleaning a lot easier because you can just rinse it out. So, but there's just small behaviors like that. And then at the end of the day, we don't want to be putting these plastic appliances in the dishwasher. Dishwashing detergent is very caustic, and it's literally designed to dissolve crusted on food. And so if there is no food crusted on, it's just really, really, really hard on plastics. We see plastics that have been in the dishwasher for a long time and they're foggy and scratched up. Why? Abrasion. So the surfaces are abraded. That just is increasing the rate of these chemicals that are migrating out. So we just kind of have to care for these plastics a little bit differently. So hand wash them, use a soft sponge, don't scrub the inside of your food processor or blender. There are some companies like Vitamix does make a stainless steel carafe for their blenders. It's like a $200, $250 replacement carafe. So it's, again, not cheap. And if somebody doesn't need a super, ultra horsepower a blender, you can still find blenders that have a glass carafe. So, we just want to kind of behave differently around these materials.
That's great. No, super helpful. And it's even an important reminder for people like myself. I am lucky, enough to have somebody who helps, come once a week or twice a week to come and clean a little bit in the house. I'm busy. I'm running a bunch of companies. I'm trying to do my podcast. I want to put my time in that area. And I've forgot to tell this individual that, oh my gosh, the Vitamix, it'd be great if we can actually just wash by hand. Or even sometimes when I make my wife a smoothie or she makes me a smoothie, it's sometimes just easy to think, oh, we're just going to dump it in the, dishwasher. Again, like you said, it's not the end of the world, but as we're on our mission to minimize our overall exposure, to in totality limit our exposure to these environmental toxins, little tiny steps go a long way, right?
Absolutely. Yeah.
Yeah. And there's another category of things as we go around the kitchen and we're looking at a few different areas. Another category is, so many people not only use cleaning products in their kitchen, but they often store a lot of their cleaning products in the kitchen as well. So that's where a lot of our storage ends up being. There's been an explosion of sort of green cleaners, better alternatives, natural cleaners that are out there. And I think that a lot of people feel like, okay, I'm buying things that are at least maybe a little bit better and a step in the right direction. But what's important for us to know about cleaning products, especially in the kitchen, when it comes to reducing our environmental exposure?
Yeah, I think, look, we all want to have a clean kitchen, myself included. And, for a very long time, and like you said, things have shifted. For a very long time, if you looked at the marketing around cleaning products, it was always, industrial strength, super strong, new and improved. Like it was this, pull out the big guns and kill everything. It kills 99.99% of bacteria. Excuse me. And so that's the marketing angle, is that it kills everything. And the first thing I want to say when it comes to household cleaners is, unless somebody is immunocompromised, that degree of sanitation and disinfection is typically not necessary, even in a kitchen. Yes, we want to clean our cutting boards that had chicken and meat and, raw meats on them. Yes, we want to do that. Yes, we want to, make sure that we don't have, mold and bacteria and stuff. But as a general rule, we don't need to bring out the big guns to disinfect the hell out of everything. It's just unnecessary. And, we do have some research that suggests that overdoing it when it comes to disinfection and sanitizing surfaces could possibly be a detriment to our health. And so there is, we don't have conclusive sort of data or stance on that. But, we don't need a lot of the cleaners. Additionally, when you go to the grocery store and you go down that cleaning aisle, there's a whole aisle. There's hundreds of products there. The formulas of those products are all kind of fundamentally the same. They're not so dramatically different. Nothing bad would happen if you used a bathroom cleaner in your kitchen or vice versa. Nothing's going to happen to you. It's okay. In terms of not crossing any weird invisible marketing lines. And so to that point, we can one, simplify our cleaning routine. You average American, you go under their kitchen sink and there's 28 bottles of stuff under there. And each one has a separate job. This one's for the toilet and that one's for the sink and this one's for the tub and that one's for the counters. And it's marketing. It's a waste of money because it's unnecessary. So one, again, we can save money by just simplifying our cleaning routine. Two, in terms of the toxic chemicals, a lot of cleaning products, whether they're using, a heavy handed with fragrances, or they have ammonia, or they have other volatile organic compounds, a lot of these cleaners contain solvents, which are carcinogens. They have and release a lot of toxic chemicals into the home, into the air that we breathe. We have to remember that when chemicals are released into our home, they don't just evaporate and vanish. They're molecules. They're like physical molecules. They don't just go away. They actually settle in our homes. They settle in our house dust. And so this is, one of the sort of free and easy recommendations I often make for people is just open your windows in order to help some of those chemicals dissipate. And so these volatile chemicals, these carcinogens, these endocrine disrupting chemicals like the fragrance mixtures, aren't helping anybody. They aren't adding anything to anybody's health, and they are linked to respiratory issues, to endocrine disruption, to hormone related endpoints. They can be linked to cancers. There's also no requirement that all the ingredients on those products be disclosed. So the consumer is a little bit kind of taking people's word for it as it pertains to like the label. And that's not really fair, I think, for consumers to kind of be in a marketplace where we're just like, they have to accept the trust us, it's safe kind of marketing line, because why would I trust you? Why would I trust you? You've given me no reason to do so for a lot of these companies or industries. And so for cleaning products, I think it's, we don't need the big guns. We do want to be careful of all of these fragrances and volatile compounds. Certainly for anybody living in a home that has any kind of respiratory issues or asthma, these can be respiratory and airway irritants. Certainly for anybody who's living in a home with anybody on the autism spectrum who might have some sort of sensory issues, right? Because this is a constant exposure to fragrances and to chemicals that might be triggering to them that other people are just kind of like whatever about. The good thing is we don't, there are many, many, many inexpensive, some are more expensive, cleaning products that don't have as a point of their company, don't have any of these really concerning toxic chemicals. They don't have fragrances. They don't release toxic VOCs. They don't have any fragrance at all. And they're not caustic. And I think if we can, we want to move towards these things. If we don't need, for example, like a scrubbing bubbles, right? I think of that product. I haven't actually shopped for anything in any of these cleaning aisles in like 20 years. So I'm dating myself with a scrubbing bubbles reference. I don't even know if that's still a product that's for sale. But in the 80s, scrubbing bubbles commercials on TV were like a big deal. So, but we don't need to use a product like that. That's a time saver for sure. We can literally just use baking soda as a mild abrasive, or something like Bon Ami, which is another non-toxic mild abrasive. You can get a canister of Bon Ami usually for like $1.29. It's really inexpensive. It's a basic all-purpose abrasive. Some people certainly can go the vinegar and baking soda route for cleaning. I don't like that because I actually hate the smell of vinegar. And vinegar acetic acid is an irritant. So for people that have respiratory issues, going the other end of the extreme of the all-natural, maybe that's not it either. But thankfully, like you said, there's been this explosion of better brands and safer cleaners. I think as it pertains specifically to the household cleaner conversation, but certainly similar in lots of other facets of the toxicity conversation, things exist on a spectrum of like good, better, best. And I don't think we all, like, if people can afford best, this goes to your like splurge cookware titanium topic earlier. If people can afford a splurge, great. Do Branch Basics. It's $50 a bottle of their concentrate. It's a really great all-purpose cleaner that does laundry and toilets and kitchen sinks and everything all at once. And so we have those options, but we don't have to splurge on our household cleaners. There are better options out there.
Just by discovering cancer earlier for individuals that have it, our rates of survival increase like, exponentially. It's kind of nuts, pretty much across the board. If you can find a cancer earlier, even without sort of the whole seed and soil theory of cancer that a few people like Jason Fung have come on this podcast about, and they really recommend, getting in control of your metabolic health. My mom was diagnosed with cancer probably about 10 years ago. And the way that she found out that she had breast cancer is what happened to a lot of women. She was in the shower one day, she's, washing herself, and she felt a little lump. Yeah. And she went in And when she went in, it was diagnosed at the time as like a stage 2 cancer. And we unfortunately are this place where, even though it's America and we have all this great technology, that's how a lot of people find out about, in particular, breast cancer. Or they start to notice that something, in case of another cancer, is not working well in their body. They're having pain, they're having pressure on something, they feel something in their abdomen, they don't know what's going on. They're going in for a regular colonoscopy because maybe they have some blood in the stool and they see, oh, they have colon cancer. It's very sort of reactionary in our cancer approach.
I mean,
and the last thing I'll tie in before I tee it up for you, one of the reasons I got excited about Prenuvo is after I did my scan, there's a few celebrities that we're connected to in our podcast and our medical clinic that were really championing that they felt not that people go there just to get scanned to see if they have cancer. It's really preventative for all categories. But the ones that I felt that were being most vocal and sharing with the rest of the audience was they felt super excited about this scan helping them detect cancer years ahead, maybe even decades ahead of when they would have naturally found out about it. Any thoughts on that?
Yeah, no, I mean, there's such great stories to hear and help build awareness about what we're doing. Maybe just to jump in with a few stats first. So one of the unfortunate things about our healthcare system is we don't have that much preventive screening tests for cancer. And in fact, only 14% of cancers are caught during a routine preventative screening exam. So this would be mammogram, potentially PSA test for men, and lung cancer screening for people that meet essentially a definition of a certain number of pack years of smoking. And the other 86% of cancers are caught either incidentally or they're caught at a time when a patient presents with symptoms. And we know that oftentimes that can be when cancer is quite advanced. The average cancer is caught at late stage 2, early stage 3. And the difference between catching all those cancers at stage 1 and the average stage of diagnosis is something like 3 to 7 times better survival.
Wow.
And then even when patients present with symptoms of cancer, our health system takes oftentimes quite some time to diagnose them. So there was a study in the UK where, in fact, 50% of patients who were diagnosed with cancer were diagnosed in an acute setting, so in hospital when they presented with acute symptoms. But also in the UK, the average cancer from the time of symptoms presenting to being diagnosed is something like 6 months. So as Dr. Attia says, cancer is really a race against time. The higher the cancer load is in the body, the more difficult it is to treat it effectively. So the earlier you catch it, the better. And what Prenuvo offers is a possibility to really diagnose cancer in patients that are still asymptomatic and therefore very early.
How early? Like, let's take, for instance, breast cancer, right? And with this full body MRI scan that you guys have and the whole AI technology behind it, what's the earliest cancer that can be detected?
Sure. We typically can find cancer that's around 1 centimeter or greater. So that's 10 millimeters. That's not to say that we haven't diagnosed lesions that are very concerning, smaller than that, but also they become very difficult to biopsy, smaller than 10 millimeters. And oftentimes you can miss the lesion on the biopsy and therefore not be able to really identify one way or the other what it is that we're seeing. So it's about 10 millimeters everywhere in the body. For men, we do a detailed prostate MRI. So there we can see things a little bit smaller. But 1 centimeter might sound big to some of your audience, or might sound small, or might not be understandable because we're talking about centimeters and not inches. But it's still relatively early in the life cycle of a cancer.
Is that generally, that won't even be, in most people, that's going to be probably either stage 0 or stage 1, right?
Correct. It would be stage 1. It would be cancer still localized to the organ of origin. And that represents the vast majority of cancers that we're diagnosing.
Yeah, that's huge.
And it also really represents just the way cancer grows. So cancer grows obviously geometrically. So it starts with 1 cell and then 2 and then 4 and then 8 and so on. But also cancer has to acquire a certain set of mutations to sort of proceed to the next stage. So we can spend quite some time at an early stage. In fact, if the average pancreatic cancer, there was a study at Hopkins a few years ago where they looked at the average age of a pancreatic cancer at the time of death of the patient. And they were able to age these cancers as being somewhere between, I think, 7 or 8 years. And when we are seeing pancreatic cancer at Pronuvo, the vast majority of those diagnoses are still confined to the organ of origin so early. And it sort of makes sense that in the 7-year lifespan of a cancer, there's probably a couple of years where it's too small even for us to see. And then there's 2 or 3 years where we can still diagnose it at a very localized stage. And then it starts to sort of run away towards the end of its life.
Yeah. Well, I want to complete the story with my mom. She's doing great. It's been 10, 13 years. I can't do the math right now. And she's been fantastic. She worked with a really incredible doctor, had a whole team of individuals who were helping her. And a big part of that was, we've done some episodes on this before, but, some practitioners using therapeutic approaches like the ketogenic diet, and then significantly lowering carbohydrates in addition to all the other stuff that was there. There was plenty of things. I'm not by any means telling people that have breast cancer that it was that simple. There was a lot of stuff that she was doing and a lot of root issues, including kind of looking at some dental health items that seemed to might be connected to her situation, but she's doing great and she's cancer free.
That's great.
Yeah. But I wished I would have had that. I'm always transparent with my audience. I did your scan before, I ever had somebody from your team reach out and say, hey, would you like to have a conversation about our technology and everything? But then you guys were really kind. I said, hey, listen, I've already paid for my scan. Don't worry about giving me a free one. I've already done it. And I don't feel like the need to do it again so soon. And they were like, okay, well, what about giving it to somebody else? And I was bringing it up with my mother-in-law, Nilufar. And I was like, hey, do you want to do this scan? I typically don't accept things, from people for the audience, for like potential guests. But she was really excited and she went and did her scan and she had a chat with your team and everything. So thank you for that, of course.
No worries.
And there was a couple things that she had to pay attention to on her area, but largely it gave her kind of a sense of peace of mind. I'm sure you hear that from a lot of people that go in and do your scan.
Yeah, no, I think often people will come in worried that we might find something that is life-threatening. And of course, when we do, that's a potentially life-saving diagnosis. But also, all of us have some degree of worry about our health. When we have headaches, we have abdominal pain that comes and goes. There's always that little voice potentially that is asking, well, what might this be? And I think just having that clarity and peace of mind is such a priceless thing. And particularly for patients that might have had cancer and they're worried about it coming back, or for people that might have a strong family history of cancer or aneurysm or disease, and just being able to, for those people, not being screened in some ways is affecting their quality of life.
Yeah.
Yeah.
So just to set the stage a little bit more, I did my scan in January of this year. I think it was I got my results back on January 27th. You have 8 clinics around the US right now, and you're probably going to be opening up more soon, I imagine. So I'm here in Los Angeles. So there's one literally down the street over here in Wilshire. What are some other cities that you guys are in right now?
So we started in Vancouver, Canada. So we screen patients there. Then we are open in Silicon Valley, in Los Angeles, in Dallas, in Boca Raton, so Southern Florida, New York, Chicago, and we'll be opening another 3 or 4 locations this year.
Yeah. So you basically make an appointment,
Yep.
right? I think you guys gave us a discount code our audience can, use, and it's not an affiliate link or anything like that. There's no compensation. Just if people want to do it, great. You get a little discount. We'll include that inside of the show notes, mention at the end. So let's say you book it. You go to the center during your appointment. The clinics are really nicely set up. They look more like a hotel lobby than they do like a doctor's office, which is always nice because there's a lot of people that are always worried. They get the anxiety, going to the hospital and sort of that very clinical white lights, everything like that. It kind of sets the stage for kind of inducing anxiety. So it's a very chill setting.
Yeah.
You go to you chill in the waiting room. They call you when they're ready. They were always on time for all my friends. I've had a buddy of mine that did it as well too, around the same time that I did it, just because he was curious. And then you get put into sort of a changing room that you have. You change into like a typical sort of, what do they call it? Like nightgowns or whatever it is.
It's a comfortable gown.
A comfortable
enough
gown.
That some people want to purchase them when they leave.
Okay.
For pajamas.
And then you go to the MRI room. And in the case of the Los Angeles, there's a few different rooms that are there. And what was really cool is that basically, the techs are all nice. They let you choose a movie on Netflix, or you can listen to a podcast on Spotify. Hopefully you guys want to listen to my podcast when you're there, but I won't be heard if you pick a documentary on Netflix or something. And then actually you are there for an hour in this full body MRI, and you kind of are just like watching a movie. And then every so often your techs there give you sort of instructions like, hey, you're going to hold your breath for about 5 seconds so they can really get a scan on a particular area. And the whole thing takes about an hour.
Yeah.
Is that generally the basic experience?
That's the general experience. And I would sort of double click on the sort of spa-like and welcoming environment, because we found just so critically important that patients really do have a negative connotation with healthcare, because our whole concept of disease is based on this idea that we diagnose things late, and therefore, if we're looking for anything, it's always going to be serious. And so anything that reminds people of this, like you said, white walls, or you won't find a white wall in one of our facilities. Our staff are very, very focused on making patients feel comfortable. And that's important because some patients might feel a little claustrophobic or a little anxious. For us, really, it all can be summed up by the fact that you are in some ways our customer. And in most imaging settings, the insurance company is the customer. And that means that we want to make sure that you feel comfortable and supported in this journey to better health.
What is the test the best at looking at? And then also, where are their limitations? No one test, as many clinicians on our podcast have talked about, we're not at the level yet where we're living in the Star Trek, age, where you can literally go to one scan and you find out everything in your body.
Yeah.
Right. So every test has things that it's great at, and every test is going to have limitations. So tell us about, what is a test good at looking at? What are the most common things where it really feels like there's actionable items that are related to where your health is for people who are wondering like, hey, am I really healthy? And then where are the genuine limitations? Because we like to be honest with our audience and share them like, hey, great. Like, you may not know about this or that, but you'll still know about these things, which could make it worthwhile to do.
Sure. Well, the best way to think about this is there's sort of two screening modalities that have historically been used for whole body. And the first one is CT. And CT is an X-ray essentially that spins around your body. So you can take a three-dimensional picture by taking hundreds of little X-rays. And then there's MRI. CT actually was a technology that a couple of companies deployed in shopping malls 20 or 30 years ago, and you could go there and get a whole body scan using a CT machine. And the problem with CT was that it didn't image soft tissue very well. As an X-ray, it's very good at bones. It's very good at imaging calcium in the body, but it's not very good at soft tissue. And a lot of the concern, in fact, that physicians have about screening in general really is rooted in this phase 20 years ago where people were doing this with CT machines. MRI is it's an imaging modality that doesn't involve radiation. We use magnetic waves to look inside your body, and it's very, very good at soft tissue. And that means that it's very good at identifying physiological conditions that we might see in almost any organ of the body. There's one exception, which is the heart. And the heart really is, you can take beautiful images with MRI, but it just takes a long time. And the reason for that is that your heart is always beating and you're always breathing. So there's a couple of things that we have to gate for. And so we, at the moment, as a company, don't do detailed imaging of the heart. That's the main limitation. Whereas CT actually is quite good at this because if you're looking for any blockage of the arteries, you're essentially looking for calcification. And calcium being the same thing that bones are made of, CT being a spinning X-ray is very good at detecting. And so that's the primary limitation of the screening that we do. But one final caveat would be that this is an adjunct technology. So we don't recommend that people not do their routine screening.
Yeah, you still need your normal lab work and other stuff that you're working on with your doctor.
Correct.
This is a bonus thing.
And tests so we still recommend that women continue to get mammograms, that we continue to do colonoscopies. That doesn't mean that we obviously don't see breast cancer or that we're unable to diagnose cancer of the bowel. But certainly for anything that a physician can see with their own eyes, for example, through a scope, it's always going to be more accurate than any type of imaging.
There's obviously the mammogram topic is a very debated one, and it's the recommendations have shifted over the years. And I know you're the CEO of a company, so you may not be able to comment or whatnot, but I got to ask the question anyway. Is this scan better than getting a mammogram? Like, not that you're telling people not to get it, but is it better than getting a
Yeah.
mammogram? Like, can you detect cancers earlier than typically a mammogram would? Or is that based on sort of who is the person interpreting the data?
I think it really depends. I for sure would not answer that question. Yes, it depends on the patient and also depends on stage of life. So for postmenopausal women, well, when women go through menopause, what happens is glandular tissue in the breasts, this is the milk producing tissue, starts to convolute and turn into fatty tissue. And mammogram is very, very good at seeing through fatty tissue and seeing lesions in postmenopausal women. The problem is for women that are still premenopausal or going through menopause, there's still a lot of glandular tissue there. And it's quite difficult with mammogram to see through that tissue.
Yeah.
And so increasingly today, in fact, in a number of states, women that are premenopausal now are able to get what's called a breast MRI. And that tends to be a with or without contrast technique. And I can describe this in a little bit more detail if you like. But Prenuvo or a contrast MRI or even ultrasound is, I think, more and more being seen as a good adjunct to mammogram for women that are still premenopausal.
Yeah, I guess the question that I've always just had, and we have a physician at our clinic, Dr. Liz Boehm, who is, always discussing the nuance of this with the patients. She's a she's a cancer survivor herself, not breast cancer. And she's a nutritionist and MD and trained in functional medicine. And obviously people have to weigh their pros and cons with the physician. But the anecdotal component that I've always had is that I feel like I've heard of multiple stories of women above the age of 40 who get their regular mammograms, but then they were the first to detect the cancer in themselves just through being in the shower and kind of seeing it. So I'm like, if you're getting your normal mammograms, but then you found your cancer first yourself, or the tumor, right? Like, is the mammogram doing its job? And I'm not asking you to comment on that, but that's just an anecdotal thing that I've dealt with in my own life and with my own mom.
I think it's just a very, unfortunately, difficult part of the body to image. And if you actually go back and read the US Preventive Task Force recommendations around mammogram, where they recommend that they be performed, I believe, every 2 years for women over the age of 45. If you read why 45 was the cutoff, it has nothing to do with incidence of cancer, and it has a lot to do with just that there are a lot of false positives and false negatives with mammogram for younger women because of this dense glandular tissue. And that's why you end up with either mammogram identifying lesions and biopsying, and only 1 in 5 lesions actually is cancer. And you also have the opposite happening, which is in there being a lesion in that dense tissue that's really hard to see. And again, that's why I think a lot of women now, particularly women that have a high risk, are starting to use more than one technique, and that provides an opportunity to triangulate. Yeah.
And then there's also the pros and cons of radiation, right? That people have to weigh out and, think about, which I know my audience is obviously very concerned about, but sometimes, you need radiation to get really good results. When it comes to the heart, I had my cardiologist on the podcast and he went through my latest metabolic labs. I have familial hypercholesterolemia. My ApoB was really high. I was walking through some of the decisions that I was making with him of whether or not I get treatment. He's going to be back on the podcast. We're going to talk about that. But one of the best things is, because I come from a South Asian background, Indian, which in America has one of the highest risk of cardiovascular disease out of any ethnic minority. He turned me on to, you mentioned CT. Traditional CTs are not great at looking at soft plaque. They only look at hard plaque.
Correct.
So he put me onto a scan that we walk people through. It's called the Clearly scan. And it gave me a lot of peace of mind, not too different than doing, Prenuvo, that I, in my instance, actually had the best score that he had seen for any 40-year-old male. He had seen women that had less soft plaque, but I had the tiniest amount of soft plaque that was there. So, that was radiation, it was contrast and everything. But that type of scan, especially because I had been hearing sort of multiple different things from different practitioners, somebody saying, oh, your cholesterol is so high, you need to go on a more of a plant-based diet. And then somebody saying, no, just continue what you're doing. And his approach was more about protecting the endothelial health. And then once I got my scan done, I was like, okay, you know what? I feel really good about this. I can continue on my lifestyle and just continue to eat healthy and whole food. So, you're always weighing the pros and cons of any intervention, but I think getting these tests done is just a helpful part of you having peace of mind of making important decisions in your life.
Yeah, and we actually, a lot of patients ask me, when I go into clinics, I like to talk to people, ask them why they're there, and they ask me what else to do. And I believe, particularly for men, but also women in their 40s or 50s, if they haven't, it's worth doing, for example, a calcium score, just to understand if they have a genetic predisposition for calcification.
Have you heard of the Clearly scan?
Yeah, absolutely. And we have people that do Clearly and Preneur together.
I find that just regular CT scan, it's like almost like, I'm not saying it's not worth it, right? Because obviously it's still recommended and doctors mention it. But generally, if you're pretty healthy, like if you, like a lot of listeners on this podcast, like you're not smoking, you're not like a binge drinker, you know, you're not severely overweight, you're going to score 0, but it doesn't tell you anything.
Yeah.
But a lot of people, it gives them a false hope, from my understanding, right? I'm not a physician, but just talking to all these cardiologists, but you really want to know about soft plaque. And you could actually have a shit ton of soft plaque, but end up having a 0 or a 1 on your calcium score. That's why, like, again, I have no affiliation with Clearly. I'm just like, it gave me a lot of peace of mind for my heart health. And that's why I ended up doing it and sharing the results with people. And actually with Pronovo, you know, everybody's always worried. Like, I came in, I'm like, look, I'm doing everything healthy. I minimize my environmental exposure. You know, my heavy metals reports on all my labs and I'm doing with all my functional docs are great. I give good metabolic health, but shit, you know, do I have prostate cancer or something like that I need to pay attention to? And it was nice that I found out that I didn't, you know, have any of those things.
Well, I think the way I think about it is your health really is a function of 3 things: how you live your life, your genetics, and luck.
Can I pause you on genetics, right? You know, the way we always talk about genetics on this podcast and the different experts that come is that genetics may load the gun, but lifestyle pulls the trigger, right? So your genetics, in a way, because our lifestyles are so out of whack, even now we have, you know, top figures in public health here in America going on 60 Minutes and saying that, hey, obesity is genetic. And when they explain their version of what they're saying, they're really talking about epigenetics, that their lifestyle is activating these things. And so I'm not saying that genetics don't play a role, but how many chronic diseases are purely genetic related? My estimation that I've heard from individuals is like less than 5%.
Yeah, although I think what you're saying is factually correct. It's a semantic difference that matters, but in real life, oftentimes at the end of the day, this is about people understanding what's going on under the skin. And I'll give you a couple of examples.
Yeah, please.
So we almost always diagnose a spine issue with everyone that comes in. Everyone has a slip disc or something going on with them. And particularly amongst younger people today that are spending a lot of time in front of computers or they're looking at phones, we're seeing degeneration of the spine that sort of is running oftentimes 10 to 15 years ahead of where they should be given their biological age.
Yeah.
Now, the question might be, they're still asymptomatic. They feel no pain. And whether or not they're going to feel pain, oftentimes, of course, is a function of the progression of that disease process, but also maybe a function of just how narrow their spinal canal is. And there are people that have congenitally narrow spinal canals for which slip disc, a moderate or severe slip disc, is going to be debilitating to them. And there are other people where we see very severe disc slippage, but they have a very wide spinal canal and they may never be symptomatic. This may never affect their quality of life. And you were born with a wide or narrow spinal canal. So really the genetics does matter. I have a friend of mine that came in, another story, a friend of mine who came in who was a police officer in Los Angeles, and he's around 60, but he looks like he's 40. He's a very fit guy of Mediterranean heritage. And he came in and he did a scan with us and he asked me about, what else should I do? I said, well, go and get a calcium score. And he got a calcium score off the charts. And this is someone who drives through LA traffic with one of those percussion guns hitting his neck to make himself feel better. And, they went and did an ultrasound of his carotid arteries and he had quite a lot of calcification there. So he was like a few hits away from, potentially giving himself a stroke. And he had no idea. And he's a fit person that works out all the time.
Yeah.
So I do believe that genetics matter. That doesn't mean that you can't influence the outcome with your lifestyle. But we all have a certain sort of starting baseline.
Interplay.
Yeah. And if you don't know where you are on that genetic spectrum, then you don't really know what type of lifestyle interventions and with what seriousness or severity you should be pursuing in order to achieve the outcome that you want.
I would love to go to my scan for a second. So Tessa, if you could scroll down, what's cool about here on the right, I'm logged into my Pronova account. On the right-hand side, this medical images and report is kind of walking you through sort of slice by body. So this image, for those that are looking at YouTube and for listening on the podcast, we'll kind of describe it. Just describe what that image is that's there that we're taking a look at.
Well, these are all the images that we took in that 1 hour that you're inside the machine.
You're showing the inside of my body.
Absolutely. And we're rotating through a bunch of different images. Wow, it's hard to annotate as they go. But here we're looking for hardness in the body. This one as well. And this is one of the primary techniques we use to look for cancer.
Yep.
Here we're looking at your prostate. There you go.
And the way that you guys divide these images up in your findings, and of course you have like a team of, I believe, like nurse practitioners that basically hop on the phone with you afterwards.
Mm-hmm.
So you have your nervous system, respiratory system, circulatory system, endocrine system, urinary system, reproductive system, digestive system, and the musculoskeletal system. So those are the sort of systems that you've identified in the body. And what you do is you walk people through how many findings, and you categorize those findings. Can you explain how you categorize those findings?
Yeah, and this is it's a work in progress for us. So we've been doing this now for 13 years, and when we started doing these scans, really no one was using MRI to screen for cancer and disease. So we've sort of had to build a risk stratification approach for categorizing anything that we see in the body in the context of screening. So typically in the context of someone who is asymptomatic. And so as we go through every organ of the body and every condition that we look for, if we see something, we categorize it low, medium, high. And typically low or informational is just something that you should be aware of. Sometimes we'll image patients and they'll realize they won't realize they only have one kidney, or they have a horseshoe kidney. That's where when we're a fetus, our kidney, we only have one sort of organ that's fused and then it separates into two kidneys. And sometimes in about 1 in 300 people, that doesn't happen.
Wow.
And so there's these informational findings that are useful to know. They sometimes affect your risk for certain diseases. Oftentimes they don't. And then medium oftentimes are things that we just want to follow over time. And then there are what we call high sort of red findings, which are things often that require a follow-up test or additional labs or clinicals just to get closer to a diagnosis about what's going on.
Yeah, there's an alert. You need to talk to somebody, go deeper on this thing. And that's typically when people get flagged as potentially having cancer. You're not telling them that they have cancer, but you're like, hey, look, these findings, if I understand correctly, are very similar to what we think could be cancerous, a tumor. Go get it checked out. And then you might say, hey, talk to your, doctor to get a referral to an oncology team or do a biopsy or whatever. Is that right?
Yeah. And really this differentiates us from previous approaches here. So previously with CT, you would see a shadow in a liver and you wouldn't know what it was. And most people are used to looking at these things in a diagnostic context, so they have to go and investigate further. Here, the technology we're using makes it a lot easier for us to separate things into benign, don't worry about, and concerning, do something about. And what's left in the middle is a very, very small number of things that typically are just too small to characterize.
Yeah.
And the test is intended not as a one-off, but a test that you would do every year or two. And so those things that are too small to really characterize, but most likely benign, we just follow over time. And there's no greater or no more sensitive test than to compare you against you a year ago.
Sure.
And see what's changed.
So just looking at my findings here, right? I have a few things that have been sort of flagged with sort of moderate findings. One is nervous system, one is respiratory, and one is digestive system. I think the main one, and I had a call with your team, and this is just me commenting on my own findings here. Tessa, if we click on the nervous system one, I believe one of the things that showed up for me was there was some tiny lesions that they found in my brain, which is not, coming with a diagnosis, but were, hey, these lesions, the way that they were explained, are typical in the earliest stages of multiple sclerosis. It's something you want to watch, you want to pay attention to. I also reviewed with my own practitioner team, and they said, look, there could be a combination of reasons that you could have had these, and these may not be recent. They could have been something that's been there for a while. Yes, definitely pay attention. Obviously, in my instance, we've had some of the world's top experts on MS and multiple sclerosis, like Dr. Terry Walls, and I live a lifestyle that's very much in alignment with, a lot of the findings that she's seen to help you sort of be in a place where you're avoiding, a chronic diagnosis of multiple sclerosis. But that was really interesting to me, and there was a whole list of things that was presented to me by my functional medicine team that I showed the scan to that said, hey, this could have come from some sort of, MS is ultimately an autoimmune disease.
Correct. Yeah.
And in our world of functional and integrative medicine, usually autoimmune diseases come with some sense of leaky gut. Gut permeability, intestinal permeability is the first sign of an autoimmune disease coming, whether it's a Hashimoto's, whether it's a MS ultimately, or whatever it might be. So there could have been early damage that was done from the time that you were dealing with severe sort of intestinal permeability, being on antibiotics and other things like that at a stage in time in my life. It could have come from, environmental toxin exposure. But again, like your own team said, okay, great. Pay attention to it. I don't have any symptoms that are there, but it really brings up this larger point. I had a friend just literally the other week who called me up and said that, hey, I got diagnosed with multiple sclerosis. This is a young woman. She's like in her 45 years old. How she found out is that she ended up going to the emergency room, Stein Eye Center here in UCLA, because she was losing vision in one of her eyes and was like freaking out. What the hell is going on? We have an amazing emergency urgent care at UCLA for eye health. She went in and they did a bunch of tests and they said, listen, this seems like it's like the earliest stages of MS. You got to go to this doctor, and then ultimately got diagnosed with, MS. And obviously now is trying to unpack it and everything with the diagnosis. For me here, nobody wants to see that you have a lesion in your brain, even if they're tiny, and it's something to pay attention to. But yet for me, I'm the type of guy which is like, knowledge is power. Okay, cool. Let me know about this. And in combination with all the other things that I've learned from experts on here, it might even have me double down more on some of the preventative things that I personally feel and have learned from my clinical team that would keep me away from, ultimately getting, MS. Anything you want to comment on that?
Yeah, I think, a few things. First of all, I think it speaks a little bit to, again, this very reactive healthcare system that we have. And when you think about these diagnoses, your mind immediately goes to a pretty dark place. MS actually is I think about 1 in 1,000 people on average during their lifetimes will have MS, and MS has different severities, obviously, as I'm sure has been explained. But here we're picking things up potentially early enough that, again, there's a lot that you can do to manage the condition, and hopefully do so potentially without involving medication and more lifestyle related changes. MS is a tricky one. It's, of course, as you look to see things a lot earlier, MS is a clinical diagnosis, so there are other things that can cause demyelination, as I'm sure has been explained.
Like chronic mold exposure for some people.
Correct, or lupus or Lyme disease, or there's a number of these autoinflammatory diseases. Also in older patients, just vascular disease can sometimes mimic MS. So we're seeing, obviously, as you start imaging patients earlier and earlier, there are sort of two consequences. One, which I think is very positive, is you get early insight into what might be a potential underlying disease process at a time when you can do more about it. You have more options. The second also is you start to see things that might also have differential diagnoses. And how do you handle that is that you continue to monitor over time and see if this is a process that's an active process, or, as you mentioned, it might have been something that you were born with, or it might be a very stable condition that therefore is not classic for MS.
Yeah. The family members that I've told to get this test done, and one of my friends, I always let them know, like, look, you're going to find something, right? Do you have any data on what percentage of people have no findings at all?
I know we have data. There is some data on MS that I remember reading, which is now that we're doing a lot more, we're diagnosing a lot more, we're identifying it a lot earlier with imaging, that about 5 to 10% of these cases are another disease that's mimicking MS. So it's not, obviously it's not a perfect test, and that's why you follow over time.
And what I meant more so is that, like, look, everybody's going to have something, some structural components, some this, especially the older you get.
Yeah.
That we know that obviously there's this whole approach and vision of aging itself as some version of a disease, right?
Yeah.
And so naturally certain things are going to come with it. So I always tell people, your team has its own version too. Like, look, don't freak out. It's not about getting sort of overwhelmed by these things. That being said, like, I do feel my friends that have or have sought out people that are on the sort of medicine 3.0 train, that are used to saying, if you go to your regular doctor and you say, hey, look, I found this finding that's there, right? And they don't know anything about the latest in MS and some of the latest clinical trials that are happening and some of the early, evidence that we have of sort of stopping it, and even potentially, putting some of the worst type of MS, like progressive MS, which Dr. Terry Walls has shown with her, studies. They're early. If they don't know about that, I find that people get very bad advice, and that advice is, okay, just wait and see, and let's wait till this gets worse off.
Yeah.
Right. And that's where I find that I've read all about, where people are very excited about, your company and the test. I've also read the backlash that's there.
Yeah.
And we'll get a chance to talk about it. But I find that the backlash, or people, there's a doctor that I really love and respect. His name is Dr. Vinay Prasad. And he had written, because I think like Kim Kardashian did this super viral post and was talking about Pronovo and why she recommends people to do it. And I saw all these practitioners come out of the woodworks who are more in the sort of medicine 2.0 camp, that if it's not complete clinical evidence behind something, then we're like wasting their time, and we're putting all these patients on sort of a rat race of trying to figure it out. But those are people that I find that are not aware that there's so much that can be done. And this is even more of a reason why I say, if you get this scan done, which I hope a lot of people do, make sure you're working with a team that is at least in the direction of being open-minded to medicine 3.0, because for every single one of these major areas, there is already published evidence that is emerging that is cost-benefit analysis. There's going to be no harm to doing it, and they're often lifestyle interventions, radically improving your sleep, radically getting away from certain food intolerances, or discovering if you have celiac or certain autoimmune triggers with foods.
Yeah.
Consistently exercising and improving your muscle mass. There's so many things that you can do, but if your regular doctor is just going to Google, or look up, MS doesn't have any cure, so there's nothing that we can do until you have a diagnosis, then we'll treat it at that time. And I find that is very infuriating. I mean, you guys are doing your part, but then the team that they're being sent to is not being told about, or the doctors they have are not being, giving them any kind of hope that there's things that they can do today about it.
Yeah, I think there's really, to unpack it, there's two assumptions here that we're challenging. The first assumption is an assumption that physicians have, which is arming patients with information about their health is dangerous. And the second one is patients have an assumption that the physicians really understand what's going on and are going to do a great job helping them look after their health. And on the first one, when we started doing these scans, in fact, we sat down. So the radiologist sat down and spoke to every single patient immediately after the scan, and we went through the results straight away. And oftentimes these were patients that might have had indeterminate symptoms, and they really wanted to understand what was going on with their bodies. And I myself got involved 4 or 5 years ago, and I remember sitting in some of these consults. And it was incredible at the end of them. Oftentimes the patient would get up and hug the radiologist and say, like, for the first time, I feel like I really understand what's going on with my bodies. And so this opinion, this sort of anecdotal opinion that you hear sometimes from physicians, we've never seen this play out. A patient armed with knowledge feels more in control, is happier and is just relieved that someone's really telling them what's going on, and gives them agency to sort of decide what to do about their health.
Cancer is a metabolic disease, right? Is there truth to that, or is that a limited understanding of what cancer is?
So, I think, so I'll start by saying this. There's 100% truth to that. I think if you asked any oncologist or any cancer biologist, they would tell you that cancer is not only a genetic disease. There are genetic components, but it is driven by metabolism in many, many ways. And if you look at, the past, 30, 40 years of therapeutic development, a lot of the drugs that we've developed have been designed to target the metabolic components associated with the disease. So I don't think any oncologist or cancer biologist will argue that it's not a metabolic disease. It is 100% a metabolic disease, but it doesn't mean that we can ignore the genetic components that are associated with, things like mutational burden on metabolic processes in the cell. A good example that I like to give is KRAS mutation. And I point back to this. I'll talk about a paper briefly. They did a paper, I think it was back in 2016, showing that in lung cancer mouse models, you can give them, stress test the system with cigarette smoke condensate. Healthy mice, they gave them a bunch of cigarette smoke condensate, and eventually they developed a mutation in KRAS. KRAS is significantly mutated in many types of lung cancer. Now that KRAS mutation alone, despite it being present because the carcinogen induced the mutation, wasn't sufficient to develop the tumor. This points back to the two-hit hypothesis. You need more than one event. In this case, the spontaneous event of smoke exposure induced a mutation, which led to dysregulation in a metabolism associated with KRAS, which then destabilized metabolism even further, like a domino effect, which caused other things to happen, which can lead to cancer. So it's not just one event. It can be a genetic event. It can be a spontaneous event if it's a heritable mutation, or if it's like chronic exposure to smoke or drinking alcohol. But you need these events to essentially enable tumor formation. And so, again, it's hard to dissociate the genetic component from the metabolic component because they do both play with each other hand in hand. So any cancer biologist, any oncologist would tell you that both play together in disease formation for cancers. So hopefully that clarifies things.
No, it does. I mean, the thing that I take away from it is that yes and but, right? It's like all those components
It always
are
is.
together for all aspects, but especially cancer. And I think what's important, and I haven't heard you say it exactly like this, but this is the takeaway that I got from you. Like, we think of cancer as one thing, but each and every cancer is like almost like its own disease. They're very different.
Yeah.
So things that would work, which you have said, in maybe really well for one particular type of cancer, may not work as well for another particular type of cancer. That doesn't mean that we poo-poo the emerging stuff that's there, but where
Absolutely.
you are most, sounding the alarm, sometimes you'll feel frustrated about this, and I would feel frustrated if I was in your same boat too.
Who wouldn't?
Is when people exaggerate claims, and that leads to a false sense of hope for people who have cancer, or a sense of blame for people who also have cancer, whose family members have passed away from cancer, like your mom, that, it's because of this exact one thing that he or she or they didn't do, and that's why they got cancer. That's what you're really trying to make sure that, in addition to people not ignoring the basic advice that's there, that you call out, because it's quite damaging. Did I get that correctly?
Absolutely. And so that's why it's super important for me as a communicator to communicate effectively to people and honestly with 100% transparency. I find that the controversy isn't because the scientists are conveying a specific image, like, again, Seyfried, and they all have their own agenda in terms of, what they want to do in their research. But at the end of the day, they do great work. A lot of the controversy comes from, I don't know how polite to say this, but there are charlatans on social media that come out and they try and interpret my work. They try and interpret Seyfried's work. They try and interpret Longo's work. And they don't have the expertise to do so. And this isn't me bashing their intelligence. I wouldn't expect myself to go into whatever field that they do and expect to be an expert at it, just as I wouldn't expect them to come into my field of study and be a pro at reading, Walter Longo's cell papers. I can barely understand cell papers half the time because they're so complicated. I need weeks to digest it. The paper I sent you, I needed weeks to digest, months to digest, to where I was able to effectively communicate the findings from that study. And so that's where the controversy arises when you have these charlatans that come out and they make bold claims about things they essentially don't understand. A good example of this is Benazati tried to interpret Walter Longo's statements and Thomas Seyfried's studies. And he went on and was talking about a 7-day water fast. And Seyfried wrote an article later in countering Benazati's statement. It was like, I never said any of that. And it's because Benazati doesn't have the foundations to be able to understand Seyfried's work, but he's making such strong and conclusive statements from something that we don't have the ability to make those statements about. And that's what pisses me off about social media. And that's why in a recent reel that I made, I was like, people need to understand that as professionals in a specific field, we can't know everything there is to know about every field. That should be common knowledge to people. So why would we expect that somebody outside of my field of study is going to be able to accurately interpret my field without a proper education? I would have thought this was common sense, but it's so easy nowadays to go online and see people talking with such confidence that we stop to question whether or not that what they're saying is actually accurate. Because it sounds simple, it sounds logical, but at the core of it, it's not. And so that's what my content seeks to correct. I don't like calling people out. I hate it. I don't want to diminish anybody's intelligence. I don't like talking about Benazati in this light. I respect the guy. But at the same time, it's like some repercussions need to be had because the information that they're giving is inaccurate and it can lead to a cancer patient dying. And that's what kills me. Because there's nothing that hurts me more than when a cancer patient comes to me and says, my mom or somebody took this advice and they ended up essentially dying because they stopped responding to their treatment because they took some nutritional advice or they went on like a juicing fast and did all these crazy coffee enemas and garbage that you see online that has very little scientific foundation and it hurts their outcomes. And that's why we need to be super accurate about what we say.
Well, I appreciate you coming on this podcast to be able to do that. And I want to give you the platform to be able to make it happen.
Thanks, man.
There's a few things that I want to get a chance to sort of address that in a kind of continuation. And I'm not familiar with this gentleman, Benazati. I'll look him up.
Don't bother.
Kidding. Well, I'm just curious
he means
now.
Well.
Yeah, I'm curious. I like to understand the landscape. What is the history?
As you should.
What motivates people? There's probably crazy things that I believed before. Not probably. There was crazy
There's so many things. I used to believe
right?
aspartame caused cancer at some point too.
Yeah.
It doesn't, just for anybody listening.
So continuing on that idea, there's, I want, just because we featured a recent case study, I put multiple disclaimers on there saying that it was a case study, but I also, because Thomas Seyfried's work in particular has blown up on YouTube, I think our original video with him has 1 million views.
Nice.
I want to give you an opportunity to sort of provide a disclaimer for anybody watching. Let's say I'm going to take you through a few different sort of interview types that are there. Because again, you do a good job of saying, hey, what do we know? What do we not know but is potentially promising? What do we not know but is potentially harmful? And what do we know that is straight up harmful, right? So for anybody that has watched Seyfried's work, the case study that we had recently on, what is an important sort of overall message that you want to share with them that we can refer back to and link to?
Sure. I think that there's a lot of promise to be had there in terms of Seyfried's finding, in terms of combining nutritional strategies or metabolic strategies, as he calls them, with standard of care treatment. Regarding how much we know about them right now, it's limited, but the studies show really extensive promise. I would feel confident in saying that, in certain contexts like pancreatic cancers or maybe even liver cancers, kidney cancers, those sorts of things, that there's a lot of promise to be had there regarding dietary interventions and in combination with chemotherapeutics. And again, that's just oversimplifying things so people can understand the degree of what, and I think Thomas is in agreement with what he's trying to show. Full disclaimer, as Thomas has said as well, like he doesn't expect all of these people to, get off their standard of care and try these nutritional strategies. I think it's important for people to do that. But the overall premise behind what we're learning how this works is that cancer cell metabolism is very different than healthy cell metabolism. We can exploit those metabolic things by using diets to change their metabolism from kind of like an epigenetic perspective. So before a diet and after a diet, they'll have very different metabolisms. Blanket statement. One metabolism to the next after that diet, we can then give them a chemotherapeutic that would make them sensitive. But if we didn't apply that diet, they wouldn't have responded to that chemotherapeutic. That's where the importance of these dietary interventions appears to be coming out in combination with chemotherapeutics, because the diet sensitizes the cancer to the drug.
Got it.
That's the pulse press thing that he's going with.
Yeah. If you wouldn't mind, I'd love to just go through maybe a couple more of these.
Sure.
And it's not to, as you mentioned, this is not to call anybody out, but it's to sort of add to the conversation that's there. Maybe in some cases is to call some individuals out. But another person that's been on this podcast and actually wrote a book about cancer is Jason Fung.
Mm-hmm.
And what do you want individuals to know about some of the core concepts that you've heard from him? In particular, obviously he's written about diabetes and he's written about blood sugar,
diabetes
other
code,
stuff.
cancer code.
And the
he's got a
cancer
code for
code
everything.
Is primarily about like the seed and soil theory of cancer. Let's start off with that, and then you can continue on with anything you might want to add.
Sure. The seed and soil hypothesis is mostly about metastasis, but regarding Jason Fung, I will say that in general, he branches out of his area of expertise. There's a lot that he understands about cancer, but a lot of people rely on his expertise because he sounds confident that what he says is accurate. And so when he talks about the seed and soil hypothesis, these things sound intelligent, but he doesn't always convey them in an accurate sense. And this isn't an attack on him or his character. He means well, I'm sure of that. But we need to understand that he's going to have limitations in his background. He wasn't trained as a cancer biologist. So I wouldn't expect, again, that I would have the same level of understanding in his field of study. I think it was diabetes is his realm of research where he was trained. So his diabetes code book is probably going to be better than his cancer code book. The level of understanding there is going to be different. But regarding the seed and soil hypothesis, that's largely related to metastasis. So the origin of a tumor, as it grows, the characteristics from where it originates is going to be very different than where it metastasizes to, because it's going to have to change characteristics to be able to get into a different organ.
And this sounds super basic, but can you explain the difference between origin and metastases? Metastases is like the full encapsulation of the tumor, or what? Can you explain the difference between those?
Basically, a tumor where it originates is the organ that it starts growing in, the solid primary tumor. Mm-hmm. Or if it's a blood-based tumor, it's kind of different because it's in the blood. But the point of origin of a tumor is where it starts growing. Metastasis is when that tumor basically packs its bags and moves to different organs.
Got it. Spreads.
It spreads.
Yeah.
Yeah. And so in order to metastasize, again, this is also a hallmark of cancer. It's basically called epithelial to mesenchymal transition, is a long way of saying that cancer cells change their cell surface to be able to detach from a solid tumor and reattach to another type of tissue. And that's essentially metastasis in a short component. So in order to do that, the cells themselves, they degrade the membrane below it so it can detach on a solid tumor from its primary origin site. So it degrades the membrane below it to detach. And then it also needs to change characteristics to move through holes in cell walls to be able to get into the bloodstream. through blood vessels. So it kind of has to squeeze through. And so all of these things need to happen for a cancer cell to metastasize. Once it gets into the bloodstream and it gets to a different tissue of origin, it then needs to go through another change to be able to live in an organ. Certain cancers, they metastasize to specific areas because they can't survive in other organs. So, lung cancers often go to the brain because they can live in the brain. They can't live in other tissues, so they often go to the brain. They form, brain cancers or brain tumors. And that's only because they develop abilities where they can survive there. To basically take up a new seed and replant its soil, so to speak.
So
does that make sense?
I think it makes sense.
Yeah.
The sort of the conclusion of that you want our audience to understand about the seed and soil theory, the seed and soil hypothesis, is that there may be some truth to it, but it's not universally applicable in every single case of cancer. Is that
no? I would say that there's a strong degree of truth to the seed and soil hypothesis regarding metastasis. It's just the mechanistic components vary between tumors. They don't all utilize the same means of packing up their bags and going to different tissues. They might have the same sort of methodology, but the mechanistic components about how they degrade the basement membrane, the enzymes associated with that, the characteristics at which they extravasate or move through blood vessels into the blood and travel are going to be different between cancers. But the overall premise is the same regarding metastasis as a whole. So all cancers in late stage try to metastasize, and they utilize similar characteristics. Metastasis is a fact.
Got it.
The seed and soil hypothesis, despite being called a hypothesis because it's complicated, there's a variety of different mechanisms, it is very well supported.
So then when somebody like Dr. Jason Fung says, largely when I look at a lot of his advice, he's not out there advocating for people to go on a water fast. He's not, doing some of these extreme things. From having him on, kind of going through the book, The Cancer Code, when he makes recommendations of reducing visceral fat, which is something that you're on board with in general, right?
Sure, we are in agreement.
And typically, Dr. Jason Fung, with his background and probably his healthy bias of working in diabetes, he sways more low carb. So he generally recommends people obviously staying off of ultra processed foods, moving towards a more lower carb diet, and reducing their visceral fat, and in some instances, obviously reducing toxin exposure. You generally would be on board with that, but the challenge is when people speak with confidence that, well, actually, let me ask you, are there any recommendations that you have seen, not that you know every single recommendation he's made, that in that particular instance, you would feel, hey, I'm not on board with that? Or is it primarily somebody stepping out of their lane and describing something in detail that maybe they don't have the fullest understanding of?
It's mostly that. So I've heard him describe things outside of his lane in detail where he doesn't have the expertise to do so. And if he mentioned that thing about toxins, I would say that that's one of those cases. It's hard to educate people about, what is and isn't a toxin. Because from my understanding, when I've studied microbiology, there's a very big difference between what a toxin is from microbial produced species like bacteria or fungi. Things like botulinum. Botulinum is a toxin. People get Botox injections as fillers. But there's a very difference between getting like a filler and being infected by Botox to where it's making a toxin that's going to be essentially a paralytic. So that's why I try and not use those words without providing sufficient context. And I think when some people hear somebody like Jason Fung use specific jargon without identifying what that means and how that applies to reducing toxin exposure, or maybe why somebody might go low carb, then it's easy to make blanket assumptions about it. And that's where the confusion and that's just where the confusion comes from.
Yeah, got it. Makes perfect sense. I want to talk a little bit, while we have still some time here, I want to talk a little about origin story. You've shared before on multiple podcasts that a big part of your why and what drove you to be in this position where you're not only highlighting and showcasing the research that we know of, right? We never finished the list before, but it was minimize/quit smoking, minimize alcohol, maintain a healthy weight,
Sleep.
sleep, increase fiber intake.
Yeah.
Right.
It's a big one.
Get your visceral fat, down. Don't be obese. Get into a healthy body composition, and obviously practice sun safety. That was another one that was out there with skin cancers being on the rise. There's a few others that are in there that maybe I didn't acknowledge.
Those are it.
But a big part of your recommendations of doubling down on the basics, people being on guard about sensational claims, and then being optimistic about categories that might have some promise, but to understand where they have promise and where they may not have promise. A lot of what's inspired that is your own personal experience with cancer with your mom.
Mm-hmm.
Can you just chat about that for a minute?
Sure. So when I was, when I was 15, I was in high school, obviously. I was 15, ripe old age of 15. My mom got diagnosed with esophageal cancer. It was actually a misdiagnosis. Her doctor, who was had his medical license stripped later, misdiagnosed her for acid reflux, which does run in the family, but it was, he was being very adamant not to check her esophagus or do an endoscopy. And when they found the esophageal tumor, it was pretty late in terms of its development. And so, of course, with that comes very few treatment options. All this to say that my mom eventually went about a year and a half to where, she had chemotherapy. She went into remission. But as with a lot of cancer patients, the cancer comes back with a vengeance. Remission means that there's no detectable cancer. So cancer went away, and then it came back with a vengeance. And whatever tumor cells were left over that couldn't be detected didn't respond to the initial therapy. Chemoresistance is another term for that. And they just outgrew, and her body was so frail at the time that she passed away after 2 years of battling with cancer. So, when you're young, she passed when I was 17, December 18th, 2008, 10:30 a.m. Excuse me. It's hard to talk about. When you're young, it's hard to cope with that. So when she passed away, I didn't know what to do. I was on track to, I've always been fascinated with marine biology. And so I was on track to go to marine biology in school. At that time, I had also done ROTC. I was commanding officer of my unit in high school, signed the paperwork to become, an Army officer through ROTC in college, got a full ride scholarship that was revoked that year. They gave it to somebody else, basically. At that time, I didn't know what to do. My mom just died, went to school. My world was just ripped apart. My stepdad abandoned us, basically, my sisters and I. I had nobody. And so when I went to school, I was alone. I had nobody. And the Army revoked my scholarship, so I had no money. I had to transfer schools to go somewhere else. Marine biology thing just wasn't working out anymore. And I was just pissed off, man. Cancer took my hero. And so when I started taking my biology courses, because they didn't have a marine biology course at the school that I transferred to called St. Leo in Florida, St. Leo University, just outside of Tampa, I was just addicted to biochemistry. And a great model to study biochemistry is cancer, because things are kind of f***ed up in cancer. Excuse my language. They're messed up in cancer regarding metabolic perspectives. And so I became addicted to studying biochemistry from a cancer perspective. And so for me, it was a coping strategy. And I would just stay up until like 2 a.m., 3 a.m., not sleeping as I probably should have, which has probably taken some years off of my life. But I couldn't sleep until I, had answers, because it just was a way that put into perspective what my mom was going through, the level of hopelessness I felt as a 17-year-old kid. I couldn't do anything. I didn't know anything about the disease. So researching it gave me solace, peace. So that's why I do what I do. And so then I tried getting into the Moffitt Cancer Research Center. after I graduated undergrad, I did a Spark internship there and just kept going down that path of, you know, getting rejected from that, got a technician position. It was the hardest working experience of my life. The guy I worked for at the time was a slave driver. I'm already a hard worker. I'll work all hours of the night if I need to. This guy required minimum 12-hour work days, nights and weekends. I did that for 2 years and 3 months of hell until I finally got into graduate school when he moved us to the Wistar Institute in Philadelphia. And I learned of a grad school program there at the University of the Sciences. And that's when I applied to the cancer bio program there. And so, again, a lot of my mission about why I got into cancer biology stems from my experiences with my mom. And the level of hopelessness that I felt. So now, like, the reason I do what I do is I don't want to make money off this. No offense to you. I don't care to be a public figure. I don't want to be on podcasts. I just want people to better understand this disease so they can make better choices about how they reduce disease risks, whether that's cancer, heart disease, I don't care. If there's any way I can help with that, that's why I do what I do. If you don't remember my name at the end of the day, I don't care. Just do what I say. And know that the level of ethical and moral responsibility behind that is of the utmost importance to me. I want people to feel less hopeless and just take their life into control. So that's why I do what I do. And it all stems from my personal experiences with my mom. And actually the first time in my life, and I'm sorry to get emotional on this, but it is an emotional topic.
Of course.
So you know what? I'm going to stop apologizing.
No need to apologize.
The first time I felt relief from the amount of grief that I've had since I was 17 was when I defended my thesis. You know, I don't think I've told anybody this, which is kind of surprising. You know, I walked out of the room after I defended my thesis, and I just thought to myself, what do I do now? I achieved the highest degree that there is in cancer biology. What do I do with this? This is what I do. This.
Yeah.
So f*** all the noise. This is how to see through that bull.
Your mom sounds amazing, first and foremost.
She was a character.
My heart goes out to not just you now, but also 17-year-old you. And on the drive over here, we were chit-chatting a little bit about life growing up, the socioeconomic status, you know, you've kind of found yourself in limited resources. And I couldn't even imagine losing a parent and needing to navigate life and all the questions that it brought up in addition to the loss.
Yeah.
And my heart goes out to you, but also the 17-year-old you. You have a sibling,
I have 4 sisters.
You have 4 sisters.
Mm-hmm. All of them crazy.
Crazy amazing, I'm sure.
Yeah. No, I love them to pieces.
But yeah, brother, my heart goes out to you. And I appreciate you opening up because, you know.
It's a two-way street. You experience this as well. So no matter what age you're at, a cancer diagnosis, as you pointed out early in this podcast episode, it's terrifying.
It's terrifying. It's scary. It brings up so many questions. And I'm just so happy that you are doing the work that you're doing to highlight, because it is probably the most scariest disease that people can imagine. Probably that, Alzheimer's, right? Like
I'm biased in the argument.
Yeah. But both of those up there. I know when my mom first called me and privately told me, she didn't want to tell my sisters at the time because she was worried about how to share with them and she didn't know what to do. And I was living here in California and she was visiting in town. She had just received a diagnosis about 4 weeks earlier.
Yeah.
She said, I want to tell you this. And my mom is like such a strong individual. And I genuinely, in her eyes, I saw that she was both trying to be strong because she wanted to be strong for me.
She's your mom.
And she was completely unsure of where to go from there. And that feeling that you see anybody going through, let alone your mom, it's so terrifying.
Yeah.
So I just want to acknowledge you, and I want to give props to you keeping your mom's legacy alive through the work that you do, and being able to share the message on such an important topic that so many people are being touched by. And if we can create a little bit of unneeded suffering by people having access to more information, especially on the topics of prevention, which really never got that much attention, minus the kind of smoking side of it.
I mean, our healthcare system isn't exactly designed in a great way that would emphasize prevention that well.
It isn't. And, things are changing.
Yeah,
right?
It's getting better.
It's getting better. There's a lot of options. I'm not the type of person that feels that. I believe that technology, when we look at the history of technology and humanity, which has led to so many advancements for our species, the solutions come from a lot of different places, right? Like, it's not just that I'm waiting for the government to figure it out, right? I'm not just waiting for insurance to figure it out.
Right.
I'm not waiting for nonprofits to figure it out. I'm not waiting for just the private sector. We need everybody working on all aspects of health. It's that important of an issue. And we're truly, in America especially, but increasing around the world, we're at a crisis moment.
Yeah.
Where the quality of life is going down, life expectancy is going down. Obviously,
cancer rates are going down. We spoke about that. Yeah.
Yeah. Going up or going down?
Going down with age.
Yeah. Going down with age. Yep. They're increasing for people who are younger.
Increasing in prevalence.
So we need to do something about this, and we need people to first and foremost talk about it. The other thing that I want to acknowledge is that because of your background that you kind of hinted towards a little bit, your stepfather abandoning you, your mother, passing away early, you being 17, not growing up in a household that had financial stability. I also just super appreciate how often into your writing about things, especially things like the start of this conversation where we were talking about preventative measures, things that are often out of pocket right now, which, by the way, for everybody who's also listening, typically technology throughout humanity has been that way. It always starts with people who have the resources, even indoor plumbing.
Yep.
Even
it was a luxury at some point.
Even electricity. It always starts off with the people that have the resources. That's how you establish a market.
Yep.
But we can't let it end there. It has to be able to come. So I feel like as I have had all these DMs back and forth with you, and I've been binging your content over the last couple of months of us getting to know each other, I want to acknowledge you for how often you in your writing hint to the fact that we have to understand the socioeconomic component of why people don't have access to the same potential for a healthy life. And so you talk about that a lot, and I just want to acknowledge you for that because it's true. I mean, if you don't have money to spend on healthy foods, you're not going to be as healthy. You're going to buy cheap food that's there because that's what you have access to, and you're just trying to survive.
Yeah, I mean, and it's obviously no surprise you see increased risks for most diseases in places where there's low income.
Right.
So that's, again,
there's not as much access to healthcare.
Right.
You don't have insurance. Often
lower education,
higher amount of ultra processed foods in the diet, higher amount of sugar sweetened beverages, right? In some of these communities, depending on which group you're looking at. I think that's why you wrote one of your posts that I came across was why there's such higher rates, especially in like the Native American populations here in America.
Yep.
In addition to obviously different pockets of the Black community and Latin community as well.
Yeah.
Right. And then in some cases also
cultural differences too, like being Chinese.
Yeah. So I just want to acknowledge you for being able to, work that into your writing and recommendations.
I appreciate that.
Are there. I think it's an important part of the conversation. We don't talk about it enough.
Yeah. But again, I also want to point out that none of this is about me. So I appreciate the acknowledgement, but again, I can't realistically expect that everyone's going to have access to this information. So if I can share that in any way and talk about, how, these very diverse aspects of our health are going to play a role in our ability to receive good healthcare, I mean, I have to talk about those things because it's a more full picture. I can't just hyperfixate on the cancer component without considering the psychological component, the socioeconomic component, those sorts of things.
Hey, YouTube, if you enjoyed what you just saw, keep watching for more great content on how to improve your brain and your life.
Mitochondria actually play a direct role in the human stress response, including psychological stress.